So shall we start? Right.
Yep.
Okay. Okay. So I hope yesterday class everyone is able to understand, right?
Yep.
Okay. So today, okay.
Start the recording. Okay.
Yeah. Actually. Okay, so today I will talk about some tagging and trunking things. Okay, so we already did trunking yesterday in the practical. So we'll do trunk, we'll do ports as a trunk, and then you can see that both the switches are able to send their VLAN informations with each other. Okay, and after that, we are able to ping the same VLAN species. Okay, between the switches as well. So that was the last practical we'll did in the the means yesterday class. Okay, so now today we'll talk about the first is known as VLAN tagging. Okay, we'll talk about VLAN tagging. Okay, so now if we talk about the VLAN tagging, so VLAN tagging is what? VLAN tagging is like this. What happens, like if we have like this the same scenario which we will did yesterday. So like imagine we have two switches. Okay, and both the switches has same VLANs. Like in this we have PCs. We start with PC1, PC2, PC3, PC4, and then we'll go for PC5. Like this, we have eight PCs connected together. Okay, so now like what we did yesterday, we have a crosswire. Okay, and we'll connect with the switches, and we have these PCs are connected with these switches like this. Okay, so now like same we'll have like this. Okay, so now we have the VLANs as we already talked about. So like imagine over there we have a VLAN 2, and we have VLAN 3 as well, like this. Okay, the same VLAN I can create over there. We have VLAN 3 and VLAN 2 over there also, because I want that PC1 and PC2 communicate with PC5 and 6, and I want PC3 and 4 communicate with PC6 and 7. Okay, I already make this port as trunk over there also and over there also, right? Okay, this is we have VLAN 2. This is what we'll do. We'll do the study class. So we'll go for VLAN 3, and over there also we have a VLAN 2, and we have a VLAN 3 over there. Now the concept is that if we talk about these things. So now what happens in that case? Like imagine if this PC wants to send the data, PC1 PC1 wants to send the data to PC number 5. Okay, so what happens in that case? When PC sends the data, so first data goes to the switch. Okay, now as you can see that this is the kind of data we have. Like imagine we have data over there like this. Okay, this is the frame actually. Switch works on frames. This is the frame, and in that we have data. In that we have data. So like imagine this is the data we have. What PC1 wants to send on PC number 5. Now what switch do? Switch sees that okay, this frame comes from VLAN 2. So what he do? He just tag over there. He just tag the VLAN 2 over there. He just mentioned on this frame. He mentioned the VLAN 2 over there, and after that they forward this frame to the other switch. So he do tagging, this kind of tagging. So switch two. Sorry, this is not a switch one. It's switch two. So switch two is understand, or is knows that where the packet, where this frame comes from. Okay, that's what we have a tagging. Okay, so tagging means what? What happens when switch forwards any data frame to other switches, or other or their ports. Okay, it tag that frame. Okay, it tags the VLAN information too. So that's what we have a tagging, VLAN tagging. So it tags the VLAN information also, that the other switches are able to understand where the packet comes from. So once this frame comes to the switch 2. Okay, now switch 2 sees the tag of this data. It sees that, okay, the frame comes to VLAN 2, and of course it goes to VLAN 2 also. So it first is you can say that identify the, or you can say learn the MAC address, and then it sends this frame to PC5 like this in the VLAN 2. Okay, so that's what we have a VLAN tagging in that case. Okay, imagine that if this frame doesn't have a VLAN tagged on that. Okay, like imagine that if this frame doesn't have a VLAN tagged information over there. So what happens in that case? In that case, what happens? This switch broadcasts this frame to every port. Okay, this frame goes to first port, also second port, also third, fourth, and this frame also goes to on this port also, this trunk port also. Okay, understand,
Yep.
right? So this is what we have. Okay, so once if there is a untagged frame comes on the switch broadcast every time on that untagged frame. Okay, so that untagged frame travels on the bandwidth here and there. Okay, so if you have any untagged frame, what happens in that case? In that case, what happens? Switch to the broadcast. Okay, so for untagged for who is able to manage the untagged frames? The untagged frames managed by the native VLAN. Okay, which we talk about previously also, types of VLAN also. Okay, so native VLAN is used to manage the untagged frames. If any untagged frames are come on the switch. Okay, so what happens in that case? That frames automatically forward to the native VLAN, and native VLAN manage that untagged frames. Understood? So remember always that when switch sends any data between the PCs, or between the switches, switch always tag that frame. Okay, it always mention the VLAN information on that particular frame. Okay, if there no VLAN information is there. Okay, so that frame is automatically managed by native VLAN. So by default in switches, the native VLAN is VLAN one by default in the switches. Okay, so if I not create native VLAN, so by default native VLAN is considered as VLAN one. Okay, we can create the native VLAN manually too. Okay, so like this, your switch works as a tagging. Understood? Okay, so this is known as a VLAN tagging. So every switch mention the VLAN information data on the data frame.
Yep.
Understood over there, right?
Yep.
Yeah. So this is what we have VLAN tagging. Samuels, okay, and
Yes.
others able to understand these things, right?
Yes.
Okay.
Yes.
And next we have a VLAN tagging protocols too. We have a VLAN tagging protocols too. Okay. So now when we go to VLAN tagging, okay, there is the two protocol which is working automatically in VLAN tagging. So you can say that we have a types of VLAN tagging protocols. So number one we have ISL. ISL. This is the protocol name ISL. Okay, and it's a Cisco proprietary protocol. Now, what is the meaning of Cisco proprietary means? Cisco proprietary means that this protocol is working only in Cisco switches. If you are using a non-Cisco switches, so in that case ISL is not working. Okay, so this is the Cisco proprietary protocol. Cisco proprietary proprietary protocol. Okay, so it belongs to Cisco switches only. So if you work on Cisco switches, so by default ISL is working. Okay, now it when this protocol use, so it use 26 byte data also, bytes frame. So it add the 26 bytes their information on the on the frame, on the data, as you can say that. Okay. And you can say that supports only 1000 VLANs, not more than that. Means you can create 1000 VLANs if you can use this ISL tagging protocol. Okay, not more than that, because it supports only 1000 VLAN. Okay. Now next we have a dot one q protocol. Dot one q. It's a IEEE standard protocol. Okay. So it's made by IEEE, and it's a and you can say that this protocol used any switches, whether it is a Cisco switch or whether it is a non-Cisco switch. Okay. So it's made by IEEE, so this protocol we can use in every switch. Okay. And it contains only 4 byte of data. 4 bytes of data. So it adds their 4 bytes on the data. Okay. And supports 4094 VLANs. Okay. Supports 4094 VLANs, because that is the difference between ISL and dot one q. This is the major difference between dot one q and ISL. Okay. We can write over there like this also, dot one q, and we can write over there like this also, dot one q. Okay. We have two ways to write this, dot one q or dot one q, like this. Okay. So there is a difference between these two tagging protocols. So by default, if we talk about the Cisco switches, so by default it works on ISL. Okay. You can change this protocol too if you want. Okay. As per the requirements, you can change this protocol too also. Understood, all of you, right? Okay. Okay. Now, next we need to understand is that VLAN trunking. Okay. So we already did about the trunking. So whenever we can use this trunk port, so it means we are using the trunking. We are using the VLAN trunk. Okay. So now, if you talk about the trunking, so we also have some trunking protocols too, which is running. Okay. So these two protocols are used in trunking too also. Okay. Remember these things. Okay. So you go for VLAN trunking protocol. Okay. So trunking protocol also same. Let's go for ISL. Okay. And the same concept is go for dot one q. Dot one q. Okay. And the third protocol is known as DTP, dynamic trunking protocol, as you can see that. Okay. So this is the three protocol which is used in VLAN trunking protocol. Okay. So dynamic trunking protocol means where we can use dynamic auto and dynamic desirable port roles. Okay. So by default, your switches works on DTP, dynamic trunking protocol. The full form of is dynamic trunking protocols. We already talked about in the last class that port rules. Okay. So
In practice, we will need to change this in some cases,
no, we
or
not we mostly by default works on DTP as well. Okay.
yeah,
But if some cases are there, means what very rarely we can change these things. Okay. But by default we works on DTP. DTP means dynamic trunking protocol, and that we have two port roles. We already discussed about the port roles. So we have two port roles in that, the same dynamic auto and dynamic desirable. Okay.
yeah,
So these port roles are already working. Okay. So dynamic desirable work only on your layer 3 switches, like 3500 series switches. Okay. So this is what we have. So these protocols are working. Okay. So by default, now we are using a dot one q. Okay. In switches as tagging protocol, and in VLAN trunking protocol, by default we can use DTP. Okay. So these are the by default protocols we are using in the switch. If you want to change it, you can change it as well as per the requirement. Okay. Fine.
yeah.
Now this is what the concept of VLAN, VLAN tagging, VLAN trunking, VLAN tagging protocols, VLAN trunking protocols. We already did about the trunking. Okay, practical. Okay. Now now next we need to understand is, okay. So next we need to understand the type of range. I told about tell you about the types of ranges. Okay, types of um, VLAN range. VLAN ranges. So we have two types of VLAN ranges. One is standard. Standard is between 1 to 1005. Okay, which every you can say that which every VLAN is every switch is use these standard ranges. Okay, every switch, whether it's a L2 switch or L3 switch, by default standard VLANs range, this standard ranges, or every switch use me support the standard range. Now we have a extended range too. Extended. Extended we have starts with 1006 to 4094, like this. Okay, 1006 to 4094. So this VLAN range supports some switches, not all switches. Okay, maybe sometime some switches like some 2960 series switches, or maybe 3500 series switches. Okay, 3700 series switches. So some switches are support this kind of extended ranges of VLAN. Okay, not all switches are support extended ranges, but the standard ranges 1 to 1005 VLAN supported by all the switches. Okay, whether it's a L2 switch or a L3 switch. Okay, so these VLANs ranges are supported by only manageable switches. Remember these things. In non-manageable switches, we're not able to do anything. I already told you in the previous class. Okay, so that we always use VLANs in the manageable switches. If I want to modify the VLANs, if I want to configure anything on the switches, so we always use manageable switches in that case. Okay, so these are the ranges we have. So we have two types of ranges: standard and extended. Okay, so standard ranges are support every switch. As per the extended one, it supports limited switches, not all the switches. Okay, clear?
Yeah. Yeah.
Now next we need to understand is what is BTP and its works. Okay, so now we'll talk about the VTP first. So VTP is what? VTP is known as a VLAN trunking protocol. VTP, the full form of VTP is VLAN trunking protocol. Okay, now what's the use of VTP over there, and well, what is VTP first? So you can say that VTP. If we talk about the VTP, so VTP is what it is. It is used to manage VLAN database from central point. From central point. Now the question is what? Now the concept is what it is mean. Why we need? Why we can use? Why we need to manage VLAN database from the central point? Okay. Now imagine that what happens in that case. Now we talk about. We'll discuss about the VLANs concepts only in two switches, right? Okay, till now we discuss about the VLAN concepts only in two switches. We configure the VLANs only in two switches, not more than that. Okay, but imagine that if I have 20 or 25 switches, if I have imagine 25 switches or 30 switches I have in my network. Okay, and I want to create VLANs to all the switches one by one. So it's next to impossible, right? It takes so much time to configure the VLAN first. First I configure the VLAN, and then after that I configure the ports also. Okay, so it's very you can say it takes too much time to create the VLANs, to delete the VLANs in every switch, right? Okay, so what Cisco gives you, it gives you the concept of VTP. So what VTP do? Like imagine that, like imagine over there in my case, I have imagined like this. I have imagined three switches in my case. You can go, we have four switches. Imagine we have, okay, and I want that this is switch one. Starts with switch one, okay. Here's switch two, switch three, and switch four. So now imagine that I want that, but whatever VLAN I can create on the switch one, okay, that VLAN is automatically created on switch two, three, and four also. Understood?
Yeah.
Right? Like imagine that in VLAN one, I can create five VLANs. Imagine I'll start with the VLAN VLAN two to VLAN six. Okay, three, four, five, six, two, three, four, five, six, like this. Okay, I create these VLANs on my switch one. So I want that when I create these VLANs on my switch one, these VLANs are automatically created in the switch two as well. Okay, switch three as well, and switch 4 as well. I don't want to create these VLANs manually to go to every switch. I want to create VLAN only switch 1, and these VLANs are automatically create on switch 2, 3, and 4 also. Okay, understood? Okay, fine. So this is what we need for this concept. We need what we need VTP, VLAN trunking protocol. So it is used to manage VLAN databases from central point. So it means that with the help of switch one, I'm creating any n number of VLANs. These VLANs automatically create on switch two also, switch three also, and four also. I don't want to create VLANs on every separate switch. Understood? Fine, clear till now.
Yeah.
So why we can use VTP? I hope you're able to understand these things, right? Okay. Now the second point we need to understand same the same thing which I already told you in that VTP is that I already told you that it can send the notification, send modification and creation, send modification and creation to all switches in same domain. Okay. Now if I want to configure VTP, so what I need to add these all switches in the same domain. Now if I give you the example, now what is the meaning of domain over there? Domain means a group, you can say that. If we talk about the domain over there, domain means a small group, as you can say that. Like in WhatsApp we can create one group, right? Okay, so whenever I can send any message to the particular group, like imagine in that group we have 10 participants already added in that particular group. Okay, so whenever I can send any message to the particular group, all the participants are able to see that message, right?
Mhm.
Okay,
Yeah.
like same in that in the switches also. Like what can I do? I can make one group over there. Okay, I make one group over there. Imagine, fine. I make one group over there. So the domain means we can create one group. You can say that. Like imagine my group name is, imagine my group name is I go for ABC. Okay, so I create this group to all the switches manually. This is what we need to do. Okay, so I create this group. I create this same name group in all the switches. Okay, fine. So I
Yep.
create this same name group in switch one also, in switch two also, switch three also, switch four also, like this. Okay, and after that, once all the switches are in the same group. So what happens in that case? It sends their updations to all the switches easily. Okay, so like this. So what we need to create one domain, means we need to create one group. Okay, and we need number second. So we need two requirements to create the VTP. Number one, we need to create a VTP domain. Domain means group. Okay, and number second, we need to configure trunk port to all the switches. Okay, so every means on switch one to switch two, we need to create trunk port over there. So like this, over there we can create trunk port. Okay, over there also we can create trunk port. Okay, over there also we can create trunk. Over there also trunk. Over there also trunk, and over there also trunk, like this. Okay, and then once every switch has the trunk port, so it's easily sends the VLAN information to other switches. Understood, right? Samuels,
Yep.
Gabriel,
Yeah.
Winey, understand these things till now, right? Okay, so this is what we have a VTP in our cases. Now, if we talk about the VTP, some more concepts. So we need to understand one more thing also before we do the practical of VTP. We need to understand the things we call as VTP modes. Okay. Now in VTP modes, if we talk about the VTP modes, so we have you can say that we have three types of modes in VTP. Number one, we have a server mode. Okay. Number two, we have a client mode. Number three, we have a transparent mode. Please understand this modes carefully because they have some confusing in transparent mode also. They have some confused concepts there. Okay, so please try to understand this. Now, if we talk about the server mode, so we talk about the server mode. So in server mode, we can create, modify, and delete the VLANs. Okay, so by default, your all switches works in server mode. When once I enable VTP on the switches, so by default, all your switches works in server mode. So that's why we able to create a VLANs in the switch easily. We can create the VLANs, modify the VLANs, delete the VLANs as well. Understood? Okay. So by default, your switches works on server mode. So in server mode, if your switch works in server mode, so we can create, modify, and delete the VLANs. In client mode, we not we are not able to create, modify, and delete the VLANs. Okay. In client mode, we are not able to modify, we are not able to create, modify, and delete the VLANs. It's a read only mode, as you can say that. Okay. If your switch works in client mode, we not able to do anything in the in the VLANs. Okay. We just receive the updates only. That's it. Okay. Now next, we have a transparent mode. So transparent mode also, you can create, modify, and delete the VLANs. Okay. Now you ask me, sir, what is the difference? Now, what is the benefit when you create server or transparent? Now, what is the difference between server and transparent? Why we can use transparent in that case? Because in server also we can create, delete, and modify the VLANs, and transport transparent also we can create, delete, and modify the VLANs. So what's the difference between server and transparent? Okay. So I'll showing you. I'll tell you the difference between server and transparent. Okay. Let me open the new paint and then we'll discuss these things. So let imagine that I have a four switches with me. Okay. Now it has a switch one. Okay. Switch two. Switch three. Switch four. Okay. Now imagine that my switch one works in server mode. Imagine it works in server mode. Behave as a server mode. Works in server mode. My switch two works in client mode. My switch three works in transparent mode. Okay. Transparent mode. Okay. This switch works in transparent mode, and my switch 4 works in client mode again, like this. Okay. So what happens in that case? Like imagine in switch 1, I can create two VLANs, VLAN 2 and VLAN 3. Okay. So once I create VLAN 2 and VLAN 3 in server in switch 1, okay, and all the switches are connected together, and we can create trunk ports too. Okay. So what happens once I create these two VLANs? So these and we can, so this VLANs information goes to client also. Okay. This switch 2 also, this switch 2 maintain this information. It automatically create this VLAN in the server. in the switch 2. Okay, now this information goes to server 3 also, switch 3 also, and this information goes to switch 4 also, like this. Okay, like you can say that not like this, like switch information goes to switch 2, then switch 2 forward this information to switch 3, and then switch 3 forwards the information to switch 4, like this. Now what happens in that case? Once the information goes to switch 2, switch 2 maintain these updates, and it's create VLAN 2 and VLAN 3 in the switch also, in the switch 2. Switch 2 create this VLANs. Okay, so in switch 2 also we have the VLAN 2 and VLAN 3, VLAN 2 and 3 we have. Okay, in switch 2. Now, what switch 2 do? Switch 2 sends this information to switch 3 as well. Now switch 3 is a transparent mode switch. Okay, now switch 3 what switch 3 do? Switch 3 accept the information, but it not write this information in their database. Okay, switch 3 tells that, okay, I'm the independent, I'm the transparent mode, I'm the independent one, I'm not creating anything, I'm not accepting any information, or you can say that I'm not modifying anything what you give me, what you told me to modify it. Okay, but yeah, if you send me any information, or if I have in my with me, it's connected with any client switch, or if I have any other switch which is connected with me, so I forward this information to the particular switch, but I'm not creating these things, I'm not maintaining this information in my database. So in switch 3, he is not, if not create this information, he's not, the VLANs is not created in the switch 3. Okay, these VLANs are not created in the switch 3. Okay, but this switch 3 forwards the information, this information to switch 4, and in switch 4 is a client again, so he creates these VLANs, and he create the VLAN 2 and 3, like this. So this is what we have, a transparent. So transparent transparent switch, what they tell that, okay, whenever information comes from the server, I'm accepting the information, okay, but I'm not modifying that information, or I'm not maintaining that information in my database. Okay, and even if I imagine that now, if I create any VLAN in transparent mode, like imagine I can create VLAN 4 in transparent mode. Over there I can create VLAN 4. Now this VLAN 4 are not created anywhere in the any switches. This information does not goes any switch, because transparent mode says that I'm not sending my information, my updates to other switches, and I'm receiving other updates, but I'm not modifying that. I'm not maintaining that updates in my database. Okay, I'm forward the updates. It's okay, but I'm not. You can say that modify that updates in my database. So in short, this transparent switch is not sending their databases to the other switches also, and it not maintaining the other database, other updates to their database too. Understand,
Yeah.
Samuels? Others,
Yep.
right? And understand these things.
Yeah.
Okay. So this is what we have, a three types of VTP modes: server mode, client mode, and transparent mode. Okay. So let me do the practical, then we can able to understand the then more clearly. Okay. So let me open my packet tracer first. Okay, so now I'm going to take four switches now. Okay, we'll start with the switches. I'll go for one, two, three, four. So I take four switches. Okay. Now I can choose cross cables. I attach this switched with the gigabit Ethernet 0/1 port 2. This switch gigabit Ethernet 0/1/port, and then this 2 to this switch 1 first port, and this 2 to this switch first port. Okay. So now this time I can attach my switches from gigabit Ethernet ports. Okay. So this is what we have. Now let's start the configurations. So I just open in my switch one. Okay. Now I'll start with the configuration. I go for enable config T. I change the host name switch 01. Okay. Now first I need to configure VTP over there. Okay. So how we can configure VTP in that case? So let's configure VTP first. So I go for VTP. Okay. Now we need to define the domain. Okay. Now you go for domain. Now previously if I showing you the VTP status right now, as you can see that if I go to privilege mode and go for show VTP status. So in that case, as you can see that my VTP is running, as you can say that. Okay, the maximum VLAN support VTP is 255. Okay, number of existing VLANs is 5, because by default we have a 5 VLANs which is already created. We already know that. Now operating mode is server. So as you can see that by default VTP is running. Okay, and VTP operation mode by default this server operation mode is server. As you can see that. Okay, this switch operation mode is server, and VTP domain name is null right now because I'm not configuring anything in the domain mode. So that's why the VTP is not working. As you can see that it's running, the service is running, but it's not working. Why? Because I'm not setting the domain name over there. Okay, so as you can see that by default your switch works in server mode. Okay, every switch, not only this switch. If I go to switch 2, as you can see that if I click on switch 2, okay, as you can we can go for switch 2 and go for enable config T host name switch 2, and in that we can, if I go for show BTP status. So in that case, as you can see that this switch 2 also operating mode is server. As you can see that switch 2 also works in server mode. Okay, so by default every switch works in server mode. Okay, so now I'll go for switch 1 now. Now I'm going to first configure this VTP. So I go for config T, and then we can go for VTP domain. Now I define the domain name. Give any name, like I give ABC. Okay, and enter it. So you can say that changing VTP domain name from null to ABC now. Okay. Now as you can see that if I go to controls and then go for show VTP status and enter it. So as you can see that right now my VTP domain name is ABC, and this and the operation mode is server right now. Understood? Okay. Now I'm going to configure the trunk port also, because we need to configure the trunk port too. Okay. So gigabit 0/1 to 0/1, I go for that. So I go to switch 1 now, and I go for config T again, config T, and then go for interface gigabit 0/1, and then go for switch port mode trunk. Okay, fine, understood, clear. So
Yeah.
switch 1 works in which mode? Switch works in server mode right now. Okay, so my
Yeah.
switch 1 works in server mode over there. Okay, now I make my switch 2 as client. Okay, so I make my switch 2 as client, I works in client mode, and I make switch 3 as transparent, and I make switch 4 as client again. Okay, so this is what we have to configure. Now I'll go to my switch 2. Okay, so I'm in switch 2 right now, as you can see that. Now I'll go for switch 2, and then I go for config T. I need to set the VTP domain name. So domain name must be same in every switch. So domain name is ABC. Okay, and I need to change my operation mode also. So I go for VTP mode. Now we have 3 modes: client, server, transparent. So what I go for, I want to make this switch as client. Enter. So setting device to VTP client mode. Now as you can see that if I go to if I click on exit over there and go for show VTP status, and hit on enter after that. As you can see that they're showing you right now this operation mode has this switch working on as a client, and this the domain name is ABC. Okay, done. Now I need to run the this trunk command 2 on this port, gigabit 0/2. So I'll go for config T and go for interface gigabit 0/2 and enter it. Then go for switch port mode trunk. Okay, so now my switch 2 is ready. Now I'll go to switch 3.
For switch to the uplink port is also trunk.
Yeah, I make this port as a trunk, no? This gigabit 0/2.
Yeah,
Okay.
but
And
the
this one
uplink.
also is a trunk. Yeah, this one is uplink
Yeah,
because it's connected with the switch 3, no? That's why. Okay. So we need
yeah.
to create this. So now I'll go for switch 3 now. And now I'll in the switch 3, I'll go for enable and go for config T. Now I'll go for again the we need to create the VTP first. VTP domain. I'll make this is for ABC. Okay, and then we can go for VTP mode. I need to set and go for transparent. Okay, this time I make switch 3 as a transparent switch. Okay,
Yeah.
transparent mode, and then hit on enter after that. Okay, now I
And
run
the host name.
at the host name, and the trunk command I need to go for there as gigabit e0/2 also. Okay, so first I need to change the host name. Host name is switch 3, and we'll go for interface gigabit 0/2 and go for switch port mode trunk. Okay, fine. So this is what we have till switch 3. Now I'll go for switch 4. Here is my switch 4. Okay, now I'll go for enable config T host name switch 4. Now I'll go for VTP domain ABC. Okay, and then VTP mode client. I make this switch as a client. I'm sorry, client. Okay, now let's once check show VTP status. Now as you can see that we have a mode is client, we have ABC, and then you can go for that. Okay, so now every switch is configured as a VTP now. Okay, now let's see. Now I'll go to my switch 1 because I am in server. So first we can try to create VLANs on client mode. Let's see we able to create or not. So right now I'm in switch 2 and I'm going to config T and I'm creating the VLAN 2. Okay, so they're showing me that they give me the message that VTP VLAN configuration not allowed when device is in client mode. So in client mode, we're not able to create anything. Okay, that's it.
Hmm.
So now I'll go to my server 1, the switch 1 who will be coming, who working as a server. So now you can say that I'll create one VLAN 2, and I'll give name IT, and I'm going to click on exit. Now I'll create VLAN 3, and give name HR, and let's go for that. That's it. So you can say that you go for show VLAN, and you can say that I created two VLANs, VLAN 2 and VLAN 3, which is successfully created in switch 1 because it's created manually. Okay, now let's see. Now as per the concept, we need in switch 2, these two VLANs are automatically created, right?
Yeah.
Let's see. Go for show VLAN, enter it. As you can see that, see, 2 and 3 is created. Done.
Yeah.
Okay, now I'll go for my other switch 3. So as you can see that if I go to switch 3, so whether it is in this switch the VLAN is created or not, this is the transparent switch. So the VLAN is created in this switch. Let's see.
No, shouldn't be.
Yeah, it's no, it's not created, as you can see that,
Yeah.
because I already told you that it maintain the updates but it not save the updates. Okay, fine. So and if I go to the switch 4, so in switch 4 the VLAN is created because it's forward the update to. So I go to VLAN, and we can see that 2 and 3 is created. Understood?
Yeah.
Okay. Now if I create VLANs in switch 3, let's see, if I go for config T and I go for VLAN 4 and go for name MKT and enter it. So now you can see that if I go for show VLAN, so VLAN 4 is created in the switch 3 because I create manually. Now let's see any other switch is able to see this VLAN or update this VLAN, okay, in the database. You go for show VLAN in switch 1, you can see that there is no information about VLAN 4. Okay,
Yeah.
now same in switch 2 as well. Okay, you can see that, see there is no VLAN 4 information is there because transparent mode not send their information to other switches. Okay, so this is
Yeah.
what we have of VTP. Understand all of you, Samuel, Gabriel, Ioini?
Yes.
Okay, so that's what we have of VTP. Okay, so this is the some concepts of VTP, as you can see that. Now we need to understand the rest concepts too. So now in VTP, we need to understand the things also that VTP has. Now we talk about the VTP. So VTP has two versions. Okay, VTP 1 and VTP 2. We have two versions in VTP, VTP 1 and VTP 2. Okay, so by default, your switch works in VTP 2. Okay, why? Because VTP 1 works in token ring. Remember these things. Okay, so that's why by default, your VTP works on VTP 2. So as you can say that if I showing you in the switch, if I go to switch 1 and if I go for show VTP status over there, and enter it, so you can say that we have a version number is VTP version number is 2 over there. Understood? Okay,
Hmm.
fine. So by default, all the switches are works in VTP version 2. Okay. Now next we have a configuration number. Now what is the meaning of configuration revision number is there? Configuration revision number is that whenever I can modify something, okay, in my switch, this number is increasing. Okay, so it shows me that how many times I can modify my VLANs or create means how many time I modify my VLAN database. Okay, like imagine that right now I already create two VLANs, VLAN 2 and VLAN 3. Now imagine that I can create another VLAN once. Imagine I go to config T, okay, I create VLAN 5 over there. Okay, that's it. Give the name. Give me name is not necessary. Sometimes go for that. Click on exit. Now you can see that. Click on exit again. I go for show VLAN. So as you can see that VLAN 5 is created. Okay, the by default name is VLAN 0005. Okay. Now if I see the status of VTP now, show VTP status. You can see that now the configuration revision number is changed. Previously it shows me 4. Right? If I go to previous one, so it shows me 4, as you can see that. Okay, but
Hmm.
now it shows me 5. Why? Because I modify something in the VLAN
Yeah.
database.
Yeah.
Understood? Okay.
Yeah.
Understand all of you? Samuel, Huani, Gabriel.
Yep.
Okay.
Yeah.
So this is what we have a configuration revision number. So whenever I can change anything in the VLAN database, this number is increasing automatically. Okay. By default, it starts with 2. Remember these things. Okay. This configuration revision number starts with 2. I hope. By default, revision number is 2. Maybe just check once. No, it's 0. Starts with 0, right? Okay. So now next, we need to understand the third point is maximum VLAN support locally is 255. So it means that this VTP protocol is able to support only how many VLANs? 255 VLANs, not more than that. Okay, fine. So With the help of VTP, we can update only maximum of 2 to 5 VLANs updates, not more than that. Okay. Now number of existing VLAN it shows me is 8. So how your existing VLAN is 8? Existing VLANs means in this switch we have 8 VLANs. How? Let's see. Let me check once. Show VLAN. Enter it. Now you can see that. Now default, we have default VLANs also. 1, 2, 3, 4, 5. 5 VLANs is default, and we can create 3 VLANs manually. The total we how many VLANs we have? Total we have 8 VLANs in this switch. Understood? Okay.
Yeah.
Fine. So like this, they give you the information about VLAN. So in this switch VLAN, we are using 8 VLANs right now. Okay. So I hope you will understand these three terms: version, configuration, region number, VLAN supported, and existing VLANs. Right? These 4 terms. Understood? Okay.
Yeah.
Now we have a VTP operating mode also. So VTP operating mode is also known as a server. By default, it's running as a server. VTP domain name also we are able to understand is name, and then we have a option name is pruning. Okay. Now understand the concept of that. Now before we learn this pruning, okay, we need to understand the two things in the VTP. The concept name is known as VTP traffic management. Okay. Now, now what is the meaning of VTP traffic management is there? Now, what is the meaning of VTP traffic management is there? Like imagine that, like imagine this that we have one switch over there, okay, and there's again switch one, and in this switch we can attach one server too. As you can see, I have a server over there. This is my server. I can attach this server with this switch. Okay. Okay. So when your switch or you can say that start sending the VTP the VLAN data data. Okay. So what happens in that case? We a switch always do the broadcast. Okay, fine. So once if VLAN if you can say that if switch starts sending the VLAN information between the switches. Okay, so what happens in that case? It broadcasts that information to every port as well. Okay, every time when switch sends their VLAN information to other switch. Okay, so it broadcasts every time it broadcasts every time all the ports has receive all the VLAN information. Okay, so what happens in that case? Like imagine that we have a server in port 1. Like this is the port 1 to my switch. This is the port 1. Okay, and I can attach the server. So what happens in that case when this switch sends the VLAN information? So what happens? That VLAN information or goes to port 1 too, because it's do broadcast. Okay, so the switch, like imagine we have another switch 2 also, like this. This is the switch 2. Okay, now what happens, like if we can if I can modify some VLANs over there. So it sends the VLAN information. So it sends the VLAN information on this port also. Okay, on this port also. So again it's modified something, again it sends the VLAN information on this port also, and on this ports also. So unnecessarily what happens, this port get all the VLAN information, and it disturbs the server, as you can see that unnecessary packets, unnecessary VLAN information is there, and it disturbs the server. Okay, so I want that. I want that. Okay, I want to prevent this port to you can say that to accept this. I want that this port is not accept the VLAN information. Okay, so for that what we can do, we can use VLAN pruning concept. VLAN pruning. Okay, VLAN pruning. So VLAN pruning is a concept in the VLANs. With the help of VLAN pruning, we can deny the port. Okay, we tell the port, okay, you need to don't accept the VLAN information. Okay, I can deny the port that, okay, you don't want to accept the VLAN information in that case. Okay, so we can in that case we can use VLAN pruning. Okay, if you not do the VLAN pruning, okay, you need to do manually also. You need to do manually. You can on the port, and you can allow or deny the VLAN traffic on the particular port, whether this port is able to accept the VLAN traffic or not. Okay, I want that only trunk ports are able to accept the VLAN traffic. That's it. Other ports are not allowed to accept the VLAN traffic. Okay, so in what case? In that case, we can use VLAN pruning. So with the help of VLAN pruning, we can deny the port, a specified port, or all the ports. Okay, accept trunk ports. All the ports are denied in the pruning, that these ports are not accept the VLAN traffic or VLAN information.
So by default, the VLAN information is broadcast
Yeah,
to
by
all of
default,
the ports.
by default, it's broadcast all over the ports. So that's why what happens in that case. That's why there is a traffic is there. Okay, like imagine if I using the VTP. Imagine that I can modify something in the switch one. Okay, so now if I modify something in the switch one, so it sends this that information to all the ports. Okay, so we can use VLAN pruning in that case. Okay, VLAN pruning, what allows VLAN pruning is that it's not allowing the ports to accept the VLAN information. It's only allow we can allow only the trunk ports only. I want that, okay, switch one is only forward the VLAN information only the trunk ports, not other ports. So that's when we can go for we can use VLAN pruning. Understood? Okay.
Yeah.
So that's what we have of VLAN pruning in our cases. Okay. Now another very good concept in VLAN is known as a VLAN security. We have a VLAN security part is also there. Okay. I just write over there VLAN security. Now why we need VLAN security over there? VLAN security. Now VLAN security part is very important. Why? Because like imagine that a VLAN security you consider VTP security, as you can see that. Okay, now if we talk about the VLAN security or VTP security, like imagine that this switch is a server switch, right? Okay, now I am a unauthorized person, as you can say that I'm an unauthorized person. Okay, I can take my switch. Okay, this is my switch. This is switch number 5. I take my switch and I attach my switch with this switch one. I know that this switch is a server mode. Okay, and what I do, I just simply run trunk command over there. That's it. So once I run trunk command over there, so what happens? This port is automatically becoming a trunk, because because by default your switch ports working in dynamic auto. Okay, so what happens once I run on this port trunk, this port is automatically becoming a trunk, and this switch sends all the information about VLANs in this switch too. Okay, or you can say that I make my switch as a server. Okay, and I can modify the information about VLANs in this. So whatever I can modify it sends the information to this switches also, and you can see that everywhere it gives the wrong information, because I am the unauthorized person. So I want to break the network. I want to destroy the network in that case. So this is very the you can see that this is very the important point of VLAN or VTP security. Okay, so for protect this kind of things, what we can use VTP security as well. Now now in VTP security we have two ways. Either I can turn off all the unused ports. Okay, like imagine I have 26 ports in my switch. Okay, I can use only 5 ports. Rest 21 ports, I want to shut down all the 25 ports. So we can do like this also, that okay, rest the unused post I want to shut down manually. This is the one point we need to do that. Number second, we can define the VTP password also. We have the option password also. We can define the VTP password too. Okay, so as you can see that we have the protocol name MD5, which is running in the VTP. As you can see that MD5 digest, it sets the protocol. Okay, it works in the password. When I set the password, okay, in one side of the switch, I need to set the password to all the switches too. If imagine that if I set the password in the switch 1 and I have not set the password into other switches, so this switch 1 is not send their VLAN information to other switches till I not set the password to other switches too. Understood?
Can you repeat it, please?
Yeah. Like imagine that I want to go for security. So now what I do, I set the password. As you can see that I set the password over there. I set the VTP password is
Yeah.
Cisco over there in switch 1. Okay. Now my VTP domain name is domain name is ABC and the password is Cisco. VTP domain domain name is ABC and the password is Cisco. Right? Okay.
Yeah.
Now what happens in that case? What happens in that case? Now imagine that what happens in this. Now I set the domain name over there also. Okay. I set the
Yeah.
domain name over there also. Over there also ABC. Over there also I can set the domain name already ABC, and I set the domain name over there ABC too. Okay, but I've not set the password in switch 2, 3, and 4. So what happens when I do anything in the like imagine now I can create a VLAN 6 over there. Like imagine I can create VLAN 6 over there. VLAN 6 over there. Okay, so now this VLAN 6 information not sent by other switches. Why? Because once this when this switch sent going to send the VLAN 6 information, they ask to the password to this switch. If this doesn't have the password to the VTP, this switch is not send their VLAN information to this switch.
Yeah. I
Okay, so
understand.
we need to set the password to every switch also over there. Okay,
Yeah.
we need to
I
set the
understand.
same. We need to set the same password over there. We need to set the same password over the Cisco like this.
Yeah.
Understood? All of you understand this, Samuel?
Yes.
And
Yep.
yeah. So this is what we have. So we can provide. We can do the security as well. Like if you want to provide the security, so we can do the security as well. So we can use VTP password security to every switch. Okay. Or if you don't want to set the password, you just switch off your unused switches if you want. You can switch off the unused ports. Sorry, not switches, ports. Like imagine in switch 1 I can use only 10 ports out of 26, so rest 16 I want to shut down those ports manually if I want. If you want to means you can secure your VTP or VLAN database from unauthorized persons. Understood? Okay, fine. So I'll showing you how we can set the passwords. Okay, on the switches. So we already have the configurations. Okay, so now if I right now if I'm in my switch 1 and go for enable. I'm sorry, need to wait now. Okay, so I hope you're able to understand this concept, right? Okay. Okay, go for enable config T. Now I define the VTP password. So VTP password is I defined Cisco. Okay, Cisco in my case. Okay, so as you can see that setting device VLAN database password to Cisco. Okay, now we can set the password now. Now you can see that like if I create VLAN 6 over there. Okay, and then click on exit simple and go show VLAN. As you can see that I set the VLAN 6 over there. Now if I check whether I can get the information in switch 2 or not. So I go to my switch 2 and go for config T. So I just go for show VLAN first. Now you can see that I'm not means get the information VLAN 6. Why? Because I'm not set the password over there till now. Once I set the password to the switch 2, the same password which I set on which I set in switch 1, it gets the information. Like you can see that. See, if I set the password, I go to config. Oh, great. Okay, let's do in switch 4 then. Let's check with the switch 4. Show VLAN. Okay, so he's also not able to get the VLAN 6 information. Now let me set the password. Config T, go for VTP. Password is Cisco, right? And enter it. Now you can see that once I set the password, now I'll show VLAN. Now you can see that. Now just wait for a while. It shows me the VLAN 6 information too. Okay. It takes some time. Sometimes it's okay. Just take the mail information. Okay, the trunk is running. Config T. VTP password. Cisco. Okay. Exit. Show VLAN. Here it is now. Now you can see that it's get the information. You can see that. Okay. Understood. Fine. So once I set the password, it's automatically get the latest information. Okay. So that's what we have our VTP passwords. So we can secure our VTP or VLAN databases with the help of VTP password 2, or otherwise you need to manually shut down the ports which is unused. Okay, the ports which you are not used right now, so you can use this option also. Okay. Okay, understand till now, right? How we can go for that VTP. Okay, so that's what we have a VTP pruning. Okay, and we have a VTP passwords. Understood. So this is what we have. We need to understand the concept and in the VTP. Okay, so that's what we have a VTP VTP. So why we can use VTP? I hope you're able to understand these things now. Why we can use VTP? What is the purpose to behind use VTP? How we configure VTP and all the stuffs. Right? Okay.
Yeah.
Okay. Now give me 2 minutes, huh? Give me 2 minutes only.
Ok.
No, dar nu ne zici ce.
Oh. Nu zic parola mea. Păi trebuie să mă chinui ca să schimb.
Nu parola, ce îi?
Ce ceri?
Okay.
Unde o vrut să intre? Unde ai vrut
La-
să intre?
La mine pe calculator. Măi, femeie, FTTP // și merge. Și l-am pus public. Uite, Hoine, asta e fix pentru tine.
Ce?
Bagă în File Explorer. Ești gata?
Nu.
Hai că îți trimit în chatbox. Copiază LAN.
Okay, so shall we start, right?
Yeah.
Yeah.
Okay. So now we'll talk about the inter-VLAN routing, the next concept. Okay, till now we understand VLAN, VTP. Okay, I hope you will understand VLAN, what is VLAN, types of VLANs, and all the stuffs, VLAN tagging, trunking, protocols, and all the stuffs. Now we'll talk about the VTP also. Okay, VTP, how it is work, what are VTP modes and all those stuffs. Okay, now the next topic we need to understand is inter-VLAN routing. Okay, if we talk about the inter-VLAN routing, so inter-VLAN routing is what? It's a so if we talk about the inter-VLAN routing, so inter-VLAN routing means if I want to connect two or more than two VLANs together, if I want to communicate between two VLANs. Okay, like imagine that we already discussed, already talk about with if I want to segregate my ports, or if you have a different VLANs, so we're not able to communicate with each other, right? Okay, this is the concept we have. Okay, but if you want to communicate the VLANs with each other, now I want to communicate the VLANs. Now you tell me, sir, why we need to communicate the VLANs? Okay, if I need to communicate the VLANs, so why we can create the VLANs in that case? Okay, so why we can use inter-VLAN routing? Like if you want to, if you we able to connect able to communicate, you can say that communicate two or more than two VLANs or more than two VLANs together. Okay, now why we need this? Why we need to communicate two or more than two VLANs? Okay, so what happens in that case? Where we can use the inter-VLAN routings? Like imagine that we have a different companies. Like this is my company. This is the another some company. You can say that this company is you can say that some ABC private limited something. Okay, and you can say that we have another company over there. It is a separate company. Okay, and this company, you can say that name is XYZ private limited. Okay, like this. Now imagine that we have some switches over there. Okay, like imagine over there we have 10 switches over there which is working in this company, and over there we have only, you can say that 8 switches working over there. Okay, and this 10 switches, they have 3 VLANs are working over there. They have a 3 VLANs. Okay, starts with VLAN 2. VLAN 2 is working as a IT. It managed IT department. Okay, VLAN 3 work as HR, and VLAN 4 work as sales, as you can see like this. Okay, over there also they have a 3 VLANs, you can see that. Okay, but over there the concept is change. VLAN 2, you can see that, works with as a sales. It manages the sales computers. VLAN 3 manages the IT computers, and VLAN 4 manages the HR computers, like this. Okay, now these two companies has collaborated with each other. Okay, these company has collaboration, so you can say that these two companies connect with each other. It means that these companies employees are able to access the resources. It means like this, that these company users are able to access the resources from this company, and this company users are able to access the resources from this company. Like this means they have a collaboration with each other. These companies are collaborate with each other. Okay, now what I want that these IT, my ABC IT PCs are able to communicate with XYZ IT PCs. Okay, but now the problem is in ABC IT VLAN is VLAN 2, but in XYZ IT VLAN is VLAN 3. Okay, so I have two ways. Either I can use inter-VLAN routing and I communicate these two VLANs, connect together with the help of inter-VLAN routing. Or what I do, I can delete this VLAN, I can create the VLAN2 as a IT, and I can move all my ports in the IT VLAN like this. So we have two options. Either I can rearrange my physical infra, or I want to go inter-VLAN routing. So if I have these kind of cases, in that case, we can use inter-VLAN routing in that case. Okay, understood the diagram, the concept of inter-VLAN routing, why we can use inter-VLAN routing, right? Okay.
Yeah.
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 So this is the major impact, major concepts of inter-VLAN routing. So we mostly use this kind of scenarios in this kind of scenarios we can use in inter-VLAN routing. Okay. So now the concept is, if you talk about the inter-VLAN routing, so we have three methods to do inter-VLAN routing. Okay. So if I talk about the methods over there, methods of inter-VLAN routing. Routing is, number one, we can call is known as a per port. Per port. Okay, the first method is known as a per port. Per port. Okay. Now, second method we go know as, I'll let you know what is this, router on stick. Okay, and the third method is known as L3 switches. So we have these three methods we have with us. Okay, fine. So now I'll give you the example that how these three method works. So if I talk about the per port, we talk about the per port. So per port, what happens in that case? For per port, we need one router. Okay. So of course, if we go for routing, so we need at least one router. Okay. So this is my router. And we have a switch, as you can see that we have one switch like this. Okay. And this switch, we have two VLANs. Which I created two VLANs over there. Okay. We have a PCs over there. Like this, we have PCs. Now, these PCs again have connectivity like this, like this, like this, and like this. Okay. Now we have two VLANs. This is VLAN 2, and we have VLAN 3 over there, like this. Now I want to communicate these two VLANs. Okay, I want to communicate these two VLANs. What I want to communicate these two VLANs. Okay. Okay. So I want that PC1 is able to communicate with PC3 and 4, and 3, 4 also communicate to V1 and 2. Okay. So what I need to do now, if we talk about the per port concept. Per port. So in this method, what we need, like imagine if you have two VLANs, so we need two interfaces, two separate interfaces on the routers, which is directly connect to the VLANs. Okay, so it means that I need two interfaces over there, like this. I need two wires to connect with the switch on the router. Like imagine this is my interface over there, is F0/0. Okay, this is the interface name, and over there we have F0/1, like this. Okay, now this F0/0 this F0/0 connects with VLAN 2. Okay, and the gateway, this is the gateway of VLAN 2, and we need F0/1 is a gateway of VLAN 3, like this. Okay, and we need to add this ports, this port also connect with the VLAN 2. Okay, and this port also connect with the VLAN 3, like this. Okay, so it means that in this kind of method, what we need, like imagine if I have 5 VLANs, so we need 5 interfaces on the routers. So every VLAN has a separate interface to connect the router. So that's what we need in per port. So what are the disadvantage of this method is, like imagine if I have 10 VLANs, so I need on the router, I need how many interfaces? I need 10 interfaces. So that was the issue in this method. Okay, so every interface has connect with the particular VLAN, and that interface is becoming a default gateway to the particular VLAN. This is what we have. Okay, so if I go for per port, so we need to use this kind of method to implement the routing, implement the interval routing on per port method. So this is the very old method. You can say that we not use this kind of methods right now. Understood this method, all of you, right?
Yeah.
Now next, we have the another method is known as router on stick. So in router on stick, what we have only one router. The same concept is there. We have a router, we have a switch, and in that switch, the same concept, we have PCs like this. Okay, and okay, so now instead of we can connect this router to the switch also. Of course, we can go for that, and we have the same concept in there. We have again the two VLANs like this, VLAN 2, and we have a VLAN 3 also like this. Okay, okay, like this. Now in this kind of method, this method is known as router on stick. Router on stick. Okay, so now router on stick means that we not for per port we need a separate interfaces. We need a physical interfaces. Okay, if we have 5 VLANs, so we need 5 physical interfaces. But in this kind of method, what we can do, we can use sub interfaces in that case. Okay, I can like I have a port already over there. This is the port. This port, imagine this port name is F0/0. Okay, and it connect with the switch. Now what can I do? What I do in this, I divide this port into sub interfaces, and I can make sub interfaces, as you can see that. I can create 2 sub interfaces, as you can see that. Like I create over there like F0/0.1. Imagine one interface, and second one is F0/0.2. So this is the sub interface I can create. Okay, so what we can do, we can map the sub interfaces to the VLANs. Like imagine now my F0/1 maps with VLAN 2. Okay, and my F0/0.2 map with VLAN 3. Okay, so I don't want to create the sub interfaces on the routers in that kind of method. Okay, we can create sub interfaces. We can create you can see that we can create of millions and billions of sub interfaces in one port. Okay, through one port we can create millions and billions of sub interfaces. So like imagine if I have 100 VLANs, I can create in the switch. So we don't need 100 physical interface. We need only one interface, one physical interface, and I can create 100 sub interfaces in that case. So if we talk about the comparison of these two methods, so there is a cost effective. We need to implement the physical interfaces as in a per port. But over there it's a cheapest. I need only one port. I can divide this port into sub interfaces. Understood? Okay.
Yeah.
Fine. So that's what we have, a router on stick option. Clear? Okay. We need to just run the trunk command over there. We need to just run this as a trunk port. That's it. So router is able to send the trunk means the VLAN information on the switch. So that's why we need to run only trunk port over there, and this is what we have, a router on stick method. Clear? Fine. The
Yeah.
next and the beneficial method is known as layer 3 switch. So what I need to do, I do nothing. I just simple use the layer 3 switch over there. Simple, that's it. This is my layer 3 switch. And in this switch, we have a PCs down there. PC1, PC2, PC3, PC4, like this. And and these PCs are connected with the layer 3 switch. So this is my layer 3 switch, as you can see that. And I can connect my PCs with layer 3 switch. And we have a same, we have different VLANs. Okay. Now, what I need to do over there, we just run a one command on layer 3 switch, because as I already told you that layer 3 switch working as a router too. Okay, in layer 3 switch we will do routing as well. So we just run the command is name as IP routing. I just start the routing services in layer 3 switch only. That's it. And rest all layer 3 switches with the help of this routing functionality, we able to communicate between two VLANs with the help of layer 3 switch. That method is known as using L3 switches. Understood? Okay.
Yeah.
So that's the
I s-
latest. Yeah. Okay, tell me.
No, I said nice.
Yeah. So that's what we have. So this is the latest method we are using right now. Layer 3 switch method. Okay. Fine. So okay, so this is what we have, the three types of methods we have. Okay, in Inter-Vlan routing. Okay, so this method we are using. You can say that this method is very old one. Okay, we not use this type of methods, but I'll showing you the practical. Not to worry. We'll do all this all types of methods practical. Okay, fine. In the next session, we'll do all this kind of methods. Okay, practical. So right now it's 1:10 from my side. Okay.
Yeah.
So take 40 minutes break. Okay, have your breakfast or tea, whatever you want. Okay, I take my lunch and then we'll start with the practicals, interval and outing practicals.
Okay.
Okay, fine. Okay, everyone there?
Yes.
Okay, fine. So let's do the practical now. So first, we'll see this per port method. Okay. So let's leave this. Okay. Now we'll start the practical. So we need to first create the topology. So I'm using this 2811 series router. Okay. Let's see. In this router we have ports. Yes, we have two ports. Okay, fast internet two ports, 0/0 and 0/1. Okay, and we need one switch. Okay, and now we need the PCs. 1, 2, 3, 4. Okay, like this. Now we can connect the thing. So first we can need to go for straight cable. Okay, this router connects with the fast Ethernet first port. I can use 10th port. Okay, to connect this, and you have another cable. Okay, and you can use this time 20 port. Okay, so we have these we connect these things with the switch. Now we need connect the PCs with the switch. So I use the simple port 1 to PC1, 2 to PC2, 3 to PC3, and 4 to PC4. like this. Okay. Now I define the IP addresses also. So imagine that these are the same concept. We already I have a VLAN 2. This is the VLAN 2, and we have a VLAN 3 like this. Okay. Now I define the IP addresses also to the VLANs. So we have a VLAN 2 over there, VLAN 2, and using VLAN 3. Okay, like this. Now I have to define the IP addresses also. So over there, I can define the IP address like imagine 11.0.0.1. Okay. Over there, I can define 11.12.0.0.1. We have different IP network. Okay. In these PCs, I can define this PC. I can define 11.0.0.2, and the default gateway is 1. And this PC define 11.0.0.3, and the default gateway is 1. And over there you can define 12.0.0.2. Okay, and we can define 12.0.0.3. The default gateway is 12.0.0.1. Okay, fine. I can add this ports also in the VLAN. So this port, as you can see that, talk about this port. This port also belongs to this one port, also belongs to VLAN 2. Okay, and this port also belongs to VLAN 3 like this. Okay, fine. So remember these things also. We need to add these things. So this port is F0/10, and this port is F0/20. Okay. Now let's start the practical. So first we need to configure the switch. Before I configure the switch, I first configure the PC's IP addresses. So I go for DHCP IP configuration. Over there is 11.0.0.2, and the default gateway I go for 11.0.0.1. Okay. Now go to PC2. 0.0.3, 11.0.0.1 default gateway. Now PC3, 12.0.0.2, 12.0.0.1. Okay. Now PC number 4. 0.3, sorry. Like this. Now we create the VLANs on the ports. Okay. So I go for switch 1 first. Config T, VLAN 2. Okay. And then we can go for VLAN 3. Okay, fine. Now I add ports in the VLAN. So first, so port 1 and 2 and 10 add in the VLAN 2, and port 1 and 3 and 4 and 20 add in the VLAN 3. Okay, so go for first interface range F0/1 to 2, switch port mode access, then switch port access VLAN 2. Understand till now, right? Now go for interface range F0/3 to 4, switch port mode access, then switch port access VLAN 3. Okay. Now I need to, now I'm adding all these ports, these two ports in VLAN 2 and these two ports in VLAN 3. Now I'm adding this port also in VLAN 2. So the interface F0/10 also need to add in VLAN 2. Switch port access VLAN 2. Okay, and now I'm going to add this port also in VLAN 3 f0/20. So go for interface f0/20. Go for switch port mode access, then switch port access VLAN 3. Okay, done. So as per the switch configuration is done, go for this is that show VLAN. So as you can say that in VLAN 2 we have 1, 2, and 20, 10 port, and VLAN 3 we have 3, 4, and 20 port. Okay, understand right now, Daniel Samuels? Okay, so now what I need to do, I'm going to go for the router one now, and I configure the IP addresses on the ports. So I write down no over there and go for enable config T, then go for interface. The interface of this router is f0/0 maybe. Yeah, there is f0/0 and over this f0/1. Yeah. So I need to go to router one, go for interface f0/0. I set the IP address 11.0.0.1 255.0.0 for no shutdown. Okay, the port is up. Now I'll go to interface f0/1 IP address 12.0.0.1 255.0.0 for no shutdown. Okay,
Yep.
and that's it. Now let's see whether these the inter-VLAN routing is configured. Okay, so now what happens now if I trying to ping PC1 to PC3, it's able to ping. Okay, so let's see, I open the PC1 and I'm trying to ping with PC3. So ping 12.0.0.2. I think first two packets are dropped and then it start pinging. As you can see that. Okay, why the packet are dropped? Because it's learning the MAC address, switch learning the MAC address. Okay,
Yeah.
so as you can see that, so it's pinging. So that is what we have a Inter-VLAN per port. Understood? Okay.
Yeah.
Now what we can do? Now the next practical we have a Inter-VLAN, the router on stick. Okay, so let's go for router on stick then. For router on stick also, we need one router.
I have a question.
Yes.
So the packets are going through the router, yeah? From PC1 to PC3.
Yeah.
Okay.
Yeah, actually the concept is that once it start the you can say that it start forwarding the packets. So it goes like this. It goes first the switch goes this packet send packet to the router. Okay.
Yeah.
And router with on this port, it sends the packet to the router, and when router sends over the VLAN 3, so it uses this port
Yeah.
to send the packet to the router. Okay, like this.
Yeah. Okay, thanks.
Now next we need to understand is second method. Okay, so it's router 2, and we can go for switch. Use PCs. Okay. I hope till now everything is able to understand everyone, right?
Yeah.
Trying to.
Trying to. Okay. Okay, so I'll go for the same port and this. And then now this time I'll use only the one port because we have only a we have one connection because we can use the sub interfaces over there. So like this, we can use. Okay, like this. Now what we can do in this we can create two interfaces over there, sub interfaces. So I divide this port and we can create sub interfaces. So we can create like this f0/0, okay, dot 2 is mapped with the VLAN 2, and I can create one port also f0/0 dot 3 is for VLAN 3. Dot 2 I can define the IP addresses like 192 sorry dot 168 dot 1 dot 1, okay, and is for, we can go for 192.168 2.1 for this. Okay, so I map you can say that like this. Now like this, port sub interface I map to VLAN 2. Okay, so before I go for that, I first create the VLAN. So over there we have a VLANs like this. Head is the VLAN, okay, VLAN 2, and we have a VLAN 3 over there like this. Okay, so now we are able to understand is that now what we need to understand is like this f0/0 dot 2, this sub interface map with VLAN 2, okay, and this sub interface map with VLAN 3 like this. Okay, when I'm going to map the interfaces, what I need to do, I need to I need to define the protocol also. The protocols, which protocols, and the protocol which is I.1q protocol I want to accept over there, because this is not a physical interface. This is the sub interface. In sub interface, we need to manually define the trunking protocol, because we need to run the trunk command over there. Okay, on both the ports. Okay, so we need to define the trunking protocol on the sub interfaces manually, because it's a sub interface. It's a virtual interface. It's not a physical interface. So in physical interface, the trunking protocol is already running, but in the virtual interface which we created, the sub interface, in that we need to define the protocols manually. So I'll showing you how we can define the protocols manually. Okay, so let's do the practical over there. So in this port, we don't want to give any IP addresses on the physical port. Okay, I just simple up the port only. I don't want to give any IP address on the physical port. Okay, we can define the IP addresses on sub interfaces. Okay, fine. Now let's start the things over there. So first, I'm going to configure the IP addresses. Now over there, in my case, now IP addresses I can use is 192.168.1.2, and the default gateway is 192.168.1.1. The sub interface is the default gateway now. And in PC5 we can give 2. Okay, in PC6 we can give 3. So like this, we can go for 192.168.1.3. The sub interface is 192.168.1.1. Okay, now PC7 we can define like 192.168.2.2, 192.168.2.1. Okay, and PC8 we can define 192.168.2.3, 192.168.2.1 like this. Okay, so this is what we have the IP addresses. Now I'll go to the switch and do the configuration first. I make the VLANs. Enable config T, go for VLAN 2, exit, then create VLAN 3, then again exit. Okay, now go for interfaces. So interfaces f0/1 to 2. I need to define, interface range. Now go for switch port mode access, and then switch port access VLAN 2. Okay, so I successfully add these two ports in VLAN 2. Okay, now I'll go for these two ports in VLAN 3. Okay, so I'll go for interface range command. I'm using f0/3 to 4, and go for switch port mode access, then go for switch port access VLAN 3. Okay, now let's check once, show VLAN. So over there we have in VLAN 2 we have port 1 and 2 is there, and in VLAN 3 we have port 3 and 4 is there. Okay, Fine. Now we need to define the sub interfaces on the routers. So I go to router first. Okay. Now before I start the creating the sub interfaces, what I need to do, I need to just simple up the physical interface. I don't want to provide the IP address on the physical interface. I just simple up the interface only. Okay. So what I need to do for that, enable config T, go for interface F0/0. Over there, we don't want to define the IP address only, just simple write no shutdown. Should no shutdown command is to up the interface. Simple enter it. So as you can see that the interface is up. Okay, but still there is no IP address on this interface. Okay. Now just click on exit now. Now if you want to create the sub interface, so how you can create the sub interface? A simple click on interface F0/0, then define dot. Okay, and then click on question mark. So you can see that how many sub interfaces we can define in one physical port. Understood? Okay. So these are the numbers. You can say that these are the numbers through which we can through that how much ports you can create, sub interfaces ports are create. Okay. So we'll go for, so I just go for 2 and 3. So I create sub interface F0/0.2. Okay. And now I can define the IP addresses. You can see that right now I'm in sub-F. Sub-F means if we are in sub interface. We go for IP address. Now before I can go for IP address, I need to mention the protocol. Okay, so we'll write down encapsulation, then .1q. Okay, I'll go for dot, yes, dot .1q, and then I need to map this sub interface in VLAN 2. So I just write to the VLAN. Now they ask me on which VLAN you want to map this interface. I want to map this interface to VLAN 2. So I define the ID of interface is VLAN 2 and enter it. So what is the meaning of this command is that I define that you need to run on .1q protocol, and you need to map this interface with VLAN 2. Understood? This command meaning, right? Daniel, Samuel?
Yep.
Okay.
Can you tell me again what's that 2 after .1q is the VLAN?
2 is the VLAN number. Yes, it's a VLAN ID.
Yeah.
So what I
Okay.
trying to do, I map this sub interface on VLAN in VLAN 2. Okay. So
Yeah. Okay.
what this command do is, this command map this interface in on VLAN 2, and we can use .1q protocol in that case. Understood? Now
Yeah.
we can define the IP addresses. Now we can go for IP address, and we have the IP addresses on this interfaces 192.168.1.1. So I go for 192.168.1.1, give the 255.255.255.0 subnet mask, and go for no shut. So it already up. Okay. So like this. Now if you see that, if I go to a show IP interface brief command is there. So you can see that we have one sub interface is created. We have two physical interface F0/0 and F0/1. Now we have one sub interface also is there. I can say that. Understood all of you now? Samuel, understand now? Right? Now go for config T. Now I need to create another sub interface for my VLAN 3. So I go for interface F0/0 dot. This time I go for 3. Okay. And then hit on enter. Again, you can see that the port is up. Now we need to define the encapsulation first. So encapsulation, it's .1q, and I want to map this interfaces sub interface in VLAN 3. So go for 3 and enter it. Okay. Now I define the IP address. (192.168.2.1, 255.255.255.0), and then go for no shutdown is not doable because it's already up. Okay, now you can see that if I go to show IP interface brief command, and you can see that we have two sub interfaces. One is .2 and one is .3. Understood, Samuels? You
Yep.
Okay,
Yep.
then Daniel, right? So this is what we have. Okay, so like this is what we have to communicate like this. Okay, so now it's already mapped. Now let's see. Whether these ping means PCs are able to ping or not. Okay, so we can go for PC 5, and let's try to ping with PC number 7. Okay, So I am in PC5, so I ping with PC number 7, 192.168.2.2, right? The IP address of PC7 is, I think, so that's what, go for check once, IP config, yes, 2.2. So let's ping with 2.2, okay? I am in P at 2.1.1.1, you can say 1.2, like IP config, and you can see that right now I'm in 1.2 and I'm trying to ping with 2.2, a different VLAN IP PC, and you can enter it. So one or maximum two packets are lost, and then after that it's pinging. Okay, now why it is not pinging? I forget one thing. Me not make this port as trunk.
Yep.
That's why it's not pinging. Because if I'm not make this port as trunk, so he's not able to send the VLAN information to router, right? So I need to make this port as trunk too. So I go to switch and I use, which the port name is F0/10, right? So I go to switch, enable config. I'm sorry, every command I run. Okay. Now go for config T. Now go for interface F0/10. Now go for switch mode trunk. Okay. And router also, the trunk command is running maybe. It takes time. Just wait. Let's wait to up. It's green, orange now. Yeah. Now let's check once again. So now I'm going to, right now I'm again in my PC5. Okay, means I'm in 1.2 and I'm trying to ping with 2.2. So let's try to ping with 2.2 now. Now you can see that it shows me reply. Okay.
If we try a trace route,
Yeah, we can go for trace route also. You can go for that tracert 192.168.2.2. So you can see that it goes first on 1.1 and then it goes to 2.2.
yeah,
Okay, means it goes first there on this port and then it release this port and use there. Okay.
it's kind of the same like the first one, but
Yeah,
with logical ports.
yeah, but
No?
but the difference between these two is that in first one we need to assign a physical interfaces, so it's
Yeah.
expensive. But in the second one we can create a sub interfaces, so we don't need expend any money to create the sub interfaces, right?
Yeah.
Okay, that's what the difference between these two. Okay. So the last one we have a layer 3 switching. So we'll use the layer 3 switches. So this is the layer 3 switch we have. This is what we have, a layer 3 switch. Multi-layer switch is known as a layer 3 switch. Okay, it has how many ports? It has 24 ports. 24
Yeah.
ports, as you can say, 24 ports and 26 total. 24 fast Ethernet and 2 is for gigabit Ethernet. Now I can take the machines again. Some machines, 1, 2, 3, 4. Okay. Now I can use the connections. And let's create the VLANs. Same concept is there, but the difference is that I can use simple. I can use over there the layer 3 switch. So I open the layer 3 switch now. CLI. go for no, go for enable, and go for config T, and create a two VLANs, VLAN 2, VLAN 3. Go for show VLAN. As you can see that VLAN 2 and 3 is created. Now I can add same thing. I can add first 2 ports in VLAN 2 and 3-4 ports in VLAN 3. So let's go for that. Config T, interface range, have 0/122, and then go for switch port mode access, then switch port access VLAN 2. Now exit. Now go for interface range, have 0/3 to 4. Go for switch port mode access, then switch port access VLAN 3. Okay, now check it. Show VLAN. So as you can say that in VLAN 2 we have 1 or 2 port, and in VLAN 3 we have 3 and 4 port. Okay. Now what I need to do, I need to write one command only. First I need to define the IP addresses, the separate IP addresses I'm going for there. So I can use 192.168.3.2, and the default gateway you define the IP addresses 192.168.3.1. Okay, so I need to define the IP addresses on the VLANs. Okay, so I'll define there. Over there, we can use same 192.168.3.3, 192.168.3.1, the VLAN IP address, and over there we can define 192.168.4.2, 192.168.4.1. Okay.
Yep.
And over there you can go for 192.168.4.2. I'm sorry, 192.168.4.3. Say 192.168.4.1. Okay, so now in the switch I define the VLAN IP addresses also. So config T, because that VLAN is becoming an interface. We go for VLAN 2. Now this VLAN is becoming a gateway for this router. So I go for the switches. So I go for IP address and go for 192.168.3.1, 255.255.255.0. No shutdown. Okay. Go for interface VLAN 3. Define the IP address 192.168.4.1, 255.255.255.0. No shutdown. Okay. Go for show IP interface brief. Okay, so we have VLAN 1, VLAN 2, and VLAN 3. They both have the IP addresses. Now, what I need to do, I need to run the command. His name is IP routing. So we'll go for config T once. Go for IP routing. IP root, IP enable routing, IP routing. IP.
Yeah, routing is there.
The routing is there, but it's not accepting the command. I don't know. Routing. Yeah.
Because
IP routing.
it's
No, it's okay.
root, it's the same.
It's okay. It's okay. Now we go for complete. Write down the complete. Now it's okay.
Yeah.
IP routing. Now let's see whether the PCs are able to ping or not. Let's go for ping. Let's go for IP config. So right now I'm in 3.2. Okay, PC 9, and I'm going to ping with PC number 11. PC number 11 IP address is what? 4.2. Okay, so let's ping with PC 9 to PC 11. So ping 192.168.4.2. Enter it. First packet may be dropped, and after that it's pinging. Everything's fine. Here you can see that. Understood.
Okay, and if we try also trace route.
Huh? Same, because we have only one partner over there.
Yeah, but
Just go for
the
3
the
4.1 also.
the IP.
Yeah, it's 4.1
From
also. It goes to 4.1 also.
no, the IP is not 192. It's only 190.
Oh, I'm sorry. I'm sorry. That's why I go for that. Let's go for 192 over there now. Here it is. Okay,
Yeah,
so it goes to 3.1 and to 4.2. Fine. So this is what we have, the inter-VLAN routing. Okay,
yeah.
fine. So this is what three methods we have. The inter-VLAN routing is it is. Okay. So just a minute. So that's what the concept of VLAN, VTP, and inter-VLAN routing. So we need to complete these three topics today: VLAN, VTP, and inter-VLAN routing. Okay.
Yeah.
So in switching, we have you can say that STP is left. Okay, it's a very important topic in the switching, STP. So then we complete the last topic is STP, as you can see in the switching part. In STP we have, it's a very long topic. So STP, after completing the STP, in next classes onwards we'll start the routing. Okay, fine. So till now we complete VLAN, VTP, and inter-VLAN routing. Okay, now we'll start with STP now. STP, you can call, is known as spanning tree protocol. Okay. Now, what is STP? As you can say that, and what is its need? So STP is a protocol, okay, and you can say that it's already running in the switches. By default, it's running. This is the services. As you can say that it's a protocol, and it's already running in the switches. By default, it's running. Okay. Now, why we need STP? So you can say that STP is used to it is used to prevent layer 2 loops. Layer 2 loops. Okay, now what is the meaning of loops over there? Any idea the meaning of loops? Loop is what?
If we connect po- two ports from 1 to 2,
Mm-hmm.
for example,
Yeah. So what in the looping is there? Looping means like, imagine that, like, this is the concept that we have switch 1 and switch 2. We have two switches. Okay, and imagine that I want to connect these two switches with one cable. As you can say that we have a cross cable, so I can connect these two switches. Okay, now what I think that, okay, I want to connect these two switches, and these are the two these are the backbone switches, as you can see that in my organization. Okay, so I want that the one cable is not enough. If this cable is cut, or if this cable is not disconnected, so the whole network is down, because it's a very sensitive switches in my network, or you can say it's a backbone switches in my from my network. So what I do, I can create two bandwidths over there. I can use two wires. I want that, okay, if one wire is down, so at least we have second wire to send the data. Okay, so I think that, so I can connect the two wires. This is actually my thinking that I need to take the backup wires. I need to take the backup network. Okay, like if this wire is down, at least we have a backup wire with me to connect the switches. Okay, now what happens in that case? Once I did this, okay, once I did this, like imagine that this switch connects with some PC. As you can see, that we have some PC over there. Okay, here's PC1, and it sends some data to the switch, and when it sends some data to the switch, and that data is the unframed data, as you can see, that untagged data. Okay, so what happens? This data is there, this packet is there like this, and that we have the data. Okay, and now this time it's a undestination data, as you can see. There is no destination mentioned in this packet. So what happens? What that time? What switch do? Switch do the broadcast. So what happens? Like imagine they have ports also there. Some ports are also connected with the other PCs, like this. Like this, some ports are there. So what happens? This packet goes to every port. This packet goes to there also. This packet goes to there also, there also, there also. And he forward this data packet to switch 2 as well. Okay, now switch. Now this data packet comes there. Now as you can see that. Now he also not this switch also not able to you can say that search the destination. So what this switch do? This switch also do the broadcast. Okay, so in the down wire he also do the broadcast like this. He also do the broadcast over there. Also he also do the broadcast. Okay, over there also he also do the broadcast. So what happens in that case? This packet goes there, again goes there. Okay, again goes there with the help of these bandwidths. So what happens in that case? There is a loop occur, and this bandwidth, the packet, this data is traveling again and again, again and again. So what happens in that case? There is a loop occur over there. So when there is a loop in the network, so what happens in that case? Because when the loop is occurred, so what happens sometimes? It unnecessary traffic is there. Number one, if the loop is occurred, what are the disadvantage of the looping is? Number one, there is unnecessary traffic is running in the bandwidth. Unnecessary traffic. Okay. Number second, what happens in what are the effect of this looping is copy of frames, means copy of data is running. You can say that they have lots of copy of this data. Okay, because switch 1 also sends the copy, switch 2 also sends the copy, so they have so many copies are there. It's running in the bandwidth. Okay, fine. And you can say that if because of this your MAC is also unstable. MAC table is unstable, you can say that. The MAC table is also unstable because of this. Okay, so this is the a disadvantage of the looping. Okay, fine. So for avoid this looping, for avoid these things, every switch has protocol name STP is running in every switch. Okay, whether it is a L2 switch or L3 switch, it doesn't matter. STP protocol is running in every switch. Okay, now what STP do? What STP do over there in this situation? When the loop is occur, what it do? It's block automatically one port. Like imagine what STP do? STP block this switch port. It's block. This port is block. So what happens in that case? This switch is not able to forward the data packet on this particular port. So when the switch is not forward the packet, so the loop is automatically destroyed. Understood? What STP do? STP block automatically one port.
Yeah.
It doesn't matter whether it's blocked in switch 1 and whether it's blocked in switch 2. It's automatically block one port. Okay. Now the concept is how STP block the port, as you can say that. The concept is this. Now why it blocks switch 2? Why is not block switch 1? Okay, so what is the process behind it? How your STP blocks the ports? Okay, so how it blocks the ports? It blocks the port with the help of concept name is root bridge. What STP do? STP makes one switch as a root bridge. Okay, and root bridge takes the decision at which port is going to block. Understood?
Yeah.
Yeah.
Okay, so what STP do? STP makes one switch as a root bridge. Root bridge means root switch. You can call bridge, you can call switch, it's the same thing. Okay, so it makes one switch as a root bridge. Now what is the criteria to making the root bridge? The criteria is every switch has a ID. Remember these things. Okay, try to understand these things very carefully because this is also a very good concept. So it goes take the decision with bridge ID and MAC address, the lowest MAC address. Understood? Okay, bridge ID and lowest MAC address. Now remember always that every switch has an ID. Okay, that ID is known as a bridge ID, and every switch ID is same. Remember these things. Actually, the default bridge ID of switches, if you talk about the bridge ID, so its default is 32768. In packet tracer, they're showing you 32769. Okay, but actually the ID in live scenarios it shows you 32768. So it means that every switch bridge ID is same. Like there is the bridge ID is also 32768. Sorry, 32768. Okay, and over there also, then this switch also the bridge ID is same, and it's 32768. Okay, so now I already told you that every switch has the same bridge ID, so he's not able to take the decision with bridge ID. So now he checks the other thing. Other thing is lowest MAC address. If switch 1 has a lowest MAC address as compared to switch 2, so switch 1 is automatically becoming a root bridge. If switch 1 has a lowest MAC address, so switch 1 is automatically becoming a root bridge. Imagine that if switch 2 has a lowest MAC address, then switch 2 becoming a root bridge.
What's the lowest MAC address means?
Lowest MAC address means that we have a MAC address. Like if I'm showing you lowest means that it checks the MAC addresses actually. So if you see that if I showing you the switch MAC address, show STP something.
Show version or
No. Show not show version. I just go for STP concept. So there is show. Mhm. Okay, the command is not there till now. Show spanning tree, yes. Show spanning tree. Maybe status. Show spanning tree. Okay, show spanning tree. That's it. And you can see that. See, this is the address, the MAC address of the of this your system. Okay, means your switch. Okay, so if you see the MAC addresses, they're showing you the MAC addresses. Okay, now this time they're showing you the root bridge MAC address. This is the root bridge MAC address, and this is your switch MAC address. Okay, because right now we don't have a multiple switches, so this bridge is automatically becoming a root bridge because there is no multiple switch. Okay, so if you see the show version command also, over there also you can find out the MAC addresses command, MAC address also. Okay, if I go for show version command also is there, so there they're showing you the MAC address. This is the my switch MAC address. Okay,
Okay, and
and we have another switch also, they're showing me the MAC address, so they count this these values. Okay,
mhm,
so they check all the values. Okay, so as compare the values, it checks who is the lowest one and who is the highest one.
lowest as in alphabetically, no? So
Yeah, alphabetically or numerically, it's
yeah,
all different.
I
Yeah,
understand.
yeah. So that's what we have. Okay, so it checks these values. If it checks the values,
Yeah,
okay, so if switch one has lowest value, so it's the switch one also becoming a automatically becoming a root bridge.
yeah, I
Understood?
understand.
Okay,
Yeah,
fine. So this is what we have. Now, this is the by default functionality. You can see that. And now you can choose with the help of STP protocol, right? In this case, you can choose with the help of STP protocol. But I want to choose manually. Okay, I want that every time switch one is becoming a root bridge. It doesn't matter whether they have a lowest MAC address or highest MAC address. I want to become forcefully switch one is a root bridge. So
yeah,
what I need to do, I need to change in the bridge ID. Okay. So how much value I can change in the bridge ID? I can change the value is 4096 only. Okay. I can increase this much value and I can decrease this much value only. Not less than this and not greater than this. Understood? So like imagine that if I minus this value, like if I go for 32768 minus with 4096. So what happens with the answer? So this switch is automatically becoming a root bridge
yeah,
because the election is finished with the bridge ID. It's not goes on the MAC address. Okay, so this is what we have. So if you want to becoming the switch forcefully a root bridge, so you can modify the bridge ID. So what how much value you can change? Only 4096, not more than that. Okay, bridge ID changing value is this only. Okay, understood. Fine.
So this is the fixed changing value, or this is the
No,
highest?
it's a fixed one. We're
It's
not
a
able to
fixed one.
we're not
Okay,
able to decrease one. We're not able to increase one. We're able to change only this amount of value. That's it.
okay,
Okay, so that's what we have. If you want to create forcefully a particular switch as a root bridge, then you can increase or decrease this value. Okay.
yeah.
Now the next concept in this we have is primary root and secondary root. So primary root bridge and secondary root bridge. Okay, and secondary. Now, what is the meaning of primary and secondary root bridge? Now, primary and secondary root bridge are working when you have a multiple switches. Okay, like in my case, we have 5 switches like this. Okay, like this. Uh, Alright. We have a 5 switch like this. Okay. Now, what I need to do, I want that. Okay, so this switch one, switch two, switch five. Okay. Now these switches are connected with each other, as you already know this. So with the help of cross cables, we connect these switches. Okay. Now, Now what I want that right now. Imagine that my switch one is a root bridge right now. Okay, switch one is a root bridge. Okay, now I want that if this root bridge is not working, or you can say that if my switch one is down. Okay, so this is right now my primary root bridge. I want that switch 2 is becoming a secondary root bridge in that case. I want that switch 2 is becoming a secondary root bridge. Now what secondary root bridge do? So if my primary root bridge is down, as you can see that, like imagine if my primary one is down, okay, my primary root bridge is down, the secondary root bridge is automatically up and becoming as a primary root bridge. It's automatically up and becoming as a primary root bridge. Okay, so I want that switch to becoming a secondary. So we can define the primary and secondary root bridge as per my requirement also. Understood? Okay. Understand? Any doubt, any questions till now? Yes, Samuels. Any question, any doubt?
Oh, I said no.
Okay.
No questions.
Okay. So this is what we have. So we can go for root bridge and secondary root bridge also. Okay. So if my I want that if my primary root bridge is down, so we have a secondary root bridge. So I make switch 2 as a secondary root bridge, and this root bridge is becoming automatically primary. Now what happens in that case? Like what happened in case that imagine that now this switch is becoming a primary switch 2. Now in meanwhile switch 1 is up, as you can see that my switch 1 is up in that case. So what happens in that case? Now again switch 1 is automatically becoming a primary, or switch 2 is still in switch 2 is still working as a primary root bridge.
No, the first one becomes primary, no?
No. Till next elections, switch 2 is becoming a primary. It doesn't matter whether your previous primary switch is up or down.
Uh-huh.
Okay, if this switch is down and then it's go for re-elections, then this switch is becoming automatically a primary one in that case.
I see.
Understood? Okay, so that's what we have, a primary root bridge and secondary root bridge concept. Okay, fine.
Yeah.
Now next we need to understand is BPDU messages. BPDU messages. Okay, so we have a BPDU messages also. BPDU messages is what they do. It you can say that it is a data message, as you can say that. The first we need to write down, it is a data message. Transmitted across a LAN network. LAN network to detect the loops in the network. Okay, understand? It's a kind of data message. It transmitted, or you can say that it travels all over the LAN network and it detects the loop. If any loop occur, okay, so what happens? So who tells the STP that the loop is occurred? BPDU messages. This message is traveling every 3 seconds in the network. Understood? Okay.
Yeah.
So this is what we have, a BPDU messages. Now BPDU messages contain so many information too. So it contains the informations too. BPDU contains information. So what kind of information it contains? It contains like number one, it contains information regarding ports. Okay. Switches, how many switches we have. Okay. And port security, if I'm using the port security, let's go for port security as well. Port security, okay, and addresses. And addresses, what addresses we have on the ports. Okay, so regarding ports means how many ports you have in the switch, which port connect to which switch, or which port connect to which PCs. Okay, if I define the port security, so it contains the information about port security also, and the addresses, what type of addresses we can set on the ports. Okay, fine. And every 2 seconds, not 3 seconds, every 2 seconds, these BPDU messages are travel in the network. Every 2 seconds. Okay, fine. Next point in this BPDU is it contains the information regarding STP topology. So what are the topology we are using in the network? Okay, like this is the topology we have. The topology means like this is the topology we have. We have switch 1, switch 2, switch 3, switch 4, switch 5. It's switch 1 connects to switch 2, then 3, 2 to 3, 3 to 4, 4 to 5, like this. Okay, or I can use the mesh topology. Every switch connects with each other like this. Okay, so what type of topology, or what type of means a physical structure we have. Okay, how we can connect the devices with each other. Okay, so you can say that save all those informations with them. It contains all those information with them. Okay, and it travels every 2 seconds. These repetitive messages travel in the network and detect the loops. If any loop occur, BPD message is there to inform the STP that that looping is there. Okay, then STP do their work. Okay, which I already told you how STP works. Okay, so like this is the concept of BPDU and STP. This is the basic concept of STP and BPDUs. Okay, understood till
Yep.
now, right? Now next we need to understand is we have a STP switch port states. Okay, so I tell you one thing also, that if I talk about the switch, if I talk about the switch, so once you can say that, imagine that we have switch over there. I just use this switch. Okay, and once I plug the PC to this switch. Okay, it takes time to up the port. You can see that. See, if I plug this, plug the PC, plug the switch to the PC. So you can say that it shows you orange. Have you seen this orange light? Right.
Yeah.
So it takes how much time by default? It takes 52 seconds maximum to up the ports, to up the port. Okay, because every switch has STP running. I already told you. So STP has that the issue. This is the issue for STP, as you can say that. Okay, it takes how much time? It takes 52 seconds to up the port. Okay, so as you can say that, if I tell you that what they do in these 52 seconds. So this is the way, this is the states, means when you plug the PC to the switch, these are the states it using. So number one, it's go for, sorry, number one is go for blocking state first in it's in blocking state by default. Okay, number second, the state is listening state. Number third, the state is learning, then forwarding, and the last one is disabled. So these all are five. These are the states. So when you plug the PC to the switch, so the switch port uses these states, means bypass these states. That's why it takes 52 seconds. Okay. So now in blocking state, what happens? It's not able to send and receive the packets, but able to send and receive the BPDU messages. So in this state, it is not able to send and receive the data packets, but able to send and receive the BPDU messages. Okay, So what switch do in this state? If it is in blocking, if your port is in blocking state, so it shows like this. Okay. Now next, in the listening state, what it does, it only receives, it listens. You can say that it listens the BPDU messages only. Not anything else. It's not able to listen the data. It's only listening the BPDU messages in this state. Okay, understood till now? In the listening state. Okay, now in learning state, it maintains the MAC address table, as you already know that. It maintains the MAC address table. Okay. Now in forwarding state, it starts sending and receiving the packets. Start sending and receiving the data. Okay. In disabled state, it means that we shut down the port manually. Means it's not participated any STP or STP elections in that case. Okay, if my port is shut down, so it means that port is disabled. So it means that if the port is shut down, so it means that that port is not participated in the elections, STP elections. Okay.
Yeah.
Understood. So these are the ports states. So you can say that when you plug the PC, so switch port bypass all these states, and after that it's on. So it takes how many time? So you can say that in STP uh, switch port takes 52 seconds. 52 seconds to 1 minute to up the port. Okay.
Yeah.
So this is what we have. So this is the major drawback in STP. Remember these things, because in live scenarios we're not able to wait till 1 minute, because in live scenarios, if I can use IP phones on that particular port, so in 1 minute we have received so many calls, okay, in the call centers. So we're not able to survive that. So that's the loss of the company. Okay. So this is the major impact in STP. Okay. Now now I'm showing you how it go for that. So like if I go down, okay, now I'll showing you. Now we can take two switches and we'll see 1 2, okay, and we'll see I'll use the cross cables, 1 to 1 and then 2 to 2. Now you can see that. Now I'll showing you how your STP works. Like you wait some time, and after that it shows you that it's that one port is automatically blocked. So now you can see that the switch 8 one port is blocked. Okay, so if I showing you, if I click on switch 7 and if I check the status of STP in switch 7 and go for enable and go for show spanning tree and enter it, they're showing me both the ports are going in forward state. Okay, fine. And this bridge is a root bridge they're showing you. This is the root bridge. So how we can identify that the IP address of this? So this is the MAC address of this. So if you check once, now 9985. So go for show version. So if I see that this switch has MAC address is 9985, as you can see that. So it means that this switch is becoming a bridge, root bridge. And remember also that the switch who becoming a root bridge, that switch ports or that switch all ports is in forward mode. Okay, root bridge ports are never blocked. Remember these things also. Okay, so remember these things also, that root bridge ports are never blocked, never in blocked mode. Okay, so as you can see that, if you see that in the switch 7, both the ports are in forward mode. As you can see that they're showing you both the ports are in forward mode. So it means that this switch is automatically becoming a root bridge. So now if I go to the switch 8 and we can check once. For enable and just check once, show spanning tree. Now you can say that one port is blocked, as you can see that. So this port F0/2 is blocked mode and second one is forward mode. Okay, fine. And this bridge ID is this, and you can see that the priority of both the switches is 732.769. The root bridge priority is also 32769, and this bridge also has a 32769 priority. Priority means the bridge ID. Bridge ID value is 32769. It's only in the packet tracer. If you are using the live devices, so what they're showing you 32768. Okay, understood, right?
Yeah.
Okay. All are able to understand till now? Winey and Samuels, okay, right?
Yep.
Okay, fine. So any doubt, anything till now? Fine, everything is right?
It is.
Okay. Okay. So next in STP we need to understand is port roles. Like we have a VLAN port roles also. We can also assign the roles to the ports. Like same STP also assign the port roles. Okay, so we have three types of port roles in STP. Number one is root port. Okay. Number second, we have designated port. And number third is alternate port. Alternate means block port. Okay, so now we talk about the root port. Okay, so if we talk about the root port, so root port always goes to the port who goes to root switch. Okay, so now you can see that if I showing you in the figure, so over there what we have now, this is the port. This port is going to if we go for switch 8, this F0/1 port goes to the root port, the root bridge. So that port is automatically becoming a root port. Understood? Okay, the port which goes to the root bridge, okay, or which connects to the root bridge, that port is becoming a root port. Understood? Okay. And the designated port is the ports who goes to end device or non-root switch. Okay, so as you can see that if I check on my root the switch 7 is a root bridge and switch 8 is a non-root bridge, right? So if I go for a switch 7 first, I open switch 7, okay, and I check the port roles of switch 7. I go for show spanning tree. So you can say that all the ports are working as designated port. So it means that why it's designated, why? Because these two ports as goes to non-root bridge. Okay, so that's why these two ports is known as a designated port. Okay, and always remember that designated ports are always in forward mode. Designated ports are not in the block state always. Okay, designated ports always working as a forward mode. Okay, and now you can see that if I minimize this one and I go to switch 8 and I'll check with this ports. So as you can see that this is the root port. Why can root port is because this port is goes on root switch. So as you can say that this port is a root port, and second one is the alternate one. Alternate one because it's a block port. So block port always go for alternate one. Understood? Okay. Samuels, understand this? Whiny.
Yep, no worries.
Okay.
Yes.
So this is what we have. So this is the port roles we have. Okay. Fine. So the last one I already told you that the port who goes to root switch but not in forward state. Okay, so that port is known as alternate port. Alternate port means the block port. We can call alternate port is a block port. Okay, fine. So this is what we have. Okay. Now in STP we have two issues, two problems. STP issues. So if I talk about the STP issues, so we have two issues. Number one, it takes approx 1 minute, 1 minute to up the port. Number one, and number two, okay. Number two is if we have number of VLANs connected to different switch. So sometimes it block VLAN ports also for avoiding the loops. So in that case, VLAN is not working. VLAN is not able to communicate. Understood? Okay. Now, what happens in that case? In second point, if we talk about the second point, I told you that if we have number of VLANs connected to the different switch, so sometimes it blocks VLAN ports for avoiding the loops. So in that case, VLAN is not able to communicate. Like how it means, what it means? It means that, like, imagine that like this: we have a switches, and I can, in this switch we have multiple VLANs. Like, imagine, like in this switch we have two VLANs, VLAN 2 and VLAN 3, like this, VLAN 2 and VLAN 3. Okay. Now imagine that by mistake, what can I do? Or means, you can say that it's running there. Now imagine that I can use the cables. So I can plug one cable to VLAN 2 and one cable to VLAN 3. Okay. Now once I plug the two cables, so what STP do? STP block one port. Now imagine that. Imagine that in that case, what STP do? STP block this port. This port. Okay. So what happens in that case? VLAN 2 switch 2 is not able to communicate with VLAN 3 because the VLAN 3 port is blocked. As you can see that this port is blocked. Understood? Okay, so this is the major problem in VLAN, in switches, in STP, because STP makes full switch as a root bridge. It's not take care of VLANs in that case. If we need to avoid the loops, it doesn't matter whether the VLAN is blocking, or it's not able to communicate. Doesn't matter for STP. STP is straightly going to avoid the VLANs and is straightly going to block the ports.
Yeah.
Understood. So this is what the major impact of VLAN, a major impact of STP. These are the issues. These are the two important issues. Means very major issues in the STP. Okay. So STP is a Cisco proprietary protocol. So once this kind of issues are there, okay. So the another protocol is name is RSTP. Okay. Now RSTP, what RSTP do? This problem is same in the RSTP also. RSTP is known as Rapid Spanning Tree Protocol. Okay, Rapid Spanning Tree Protocol. Rapid Spanning Tree Protocol. Okay, now Rapid Spanning Tree. Now you can say that Rapid Spanning Tree Protocol is a protocol of IEEE. So IEEE makes this protocol IEEE. Okay, and the standard of protocol is using is 802.1W. This is the standard is using. Okay, now when RSTP is launched, so what in the RSTP, what they do, it resolve one problem. Which problem? This problem. Now in this case, it not takes that much. It not takes 1 minute to up the port in the RSTP case. Okay, it takes a maximum of you can say that 20-25 seconds, not more than that. Okay, to up the port. So number one, so it takes only 20 to 25 seconds, not more than that, to up the ports. Now why it happens? Why? Because if we talk about the STP port states, so over there we have 5 states. Okay, but if we talk about in the RSTP, so RSTP states are down. Okay, so in RSTP we don't have that much states. We talk about the RSTP states, so we don't have that much states. So in this we can use only discarding. Okay, learning and forwarding. Okay, discarding, learning, and forwarding. They have only these three states. Okay,
Yeah.
the blocking one and the other states, other two states are they remove these states. Okay, listening and disabled, they remove these states. Okay, so they have only the three states. Discarding means disabled, learning and forwarding. That's it. So that's why in RSTP the default time of up the port is 20 to 25 seconds, not more than that. Okay, it's improved these things. Okay, and in RSTP now if you want to I'll showing you how we can change the protocol also. But by default, I already told you that we that your switches runs in STP. Okay, and if you want to switch to RSTP, so we have the command. Okay, spanning a tree. Then we have a modes. So if I showing you in the switch, so we have a command too. So if I go for show spanning tree, then mode. Sorry, show spanning tree summary over there. If I once go for summary, they're showing me that which protocol I'm using right now. Okay, right now it's running PVST. Now what is PVST? I'll let you know what is PVST protocol. Okay, so right now it's running PVST. If I need to change this mode, okay, so the command is I need to go to config mode once and go for spanning tree mode. So these are the protocols we have, PVST and RPVSTP. If I go for rapid spanning tree protocols, I go for this one. So you can use this protocol. Go for rapid PVSTP and enter it. So now you can see that now you're working with RSTP. Okay. So now you can go for, if you check once, show spanning tree summary. So as you can see that right now I'm working now rapid PVSTP. Understood? Okay,
Yeah.
so this is what we have. So if you want to change the protocols, you can change the protocols too. Okay, as per the commands. So spanning tree mode, and if I need to go to previous one, so go for PVSTP and enter it. You go for like this. Show spanning tree summary. So as you can say that now, right now I'm working with PVSTP. Now PVSTP is not a STP one. PVSTP is a different protocol right now. Okay, so we'll discuss about PVSTP too, not to worry. So what they gives you this at the RSTP, in RSTP it improved the first problem little bit, not full improved, but yeah, a little bit improved the first problem. This, but the second problem is same again. Okay, so
Yeah.
for maintaining the second problem, or you can say that for managing the second problem, what they do now, previously we talk about means we talk about the second problem. Before, we need to understand RSTP gives you so many things also. Like if you work on RSTP, okay, so they gives you so many options too, means so many services too. So one service's name is Portfast. Portfast. Okay, it gives you Portfast. Second, it gives you BPDU guard. Okay, and number third, it gives you guard only. Guard option is also there. And number fourth, it gives you Ether channel. Okay, so these are and the last one is give you port secured. Okay, so these are the 5 functionality provided by RSTP. Okay, with them. So if you talk about the RSTP, so port fast is what? If you want to, you can say that if you want to enable the port immediately without delay. Okay, but then you can go for port fast command is there. With the help of post fast command, we can enable the port immediately. You can say that. Okay, so it is used to up the port immediately without any delay, means without any delay. Okay, fine. So this is what we have, a port fast command we have. So we need to enable this port fast command. Okay, fine. Now BPDU guard is like, if I want that, I want that, I don't want to receive BPDU messages from a particular port. Okay, so in that case, we can use BPDU guard. So if I enable BPDU guard on a particular port, so what happens in that case? Don't accept the BPDU messages on a particular interface. Okay, so that's what we have a BPDU guard is there.
Yeah.
Understood? Okay. And next, if you have we have a guard option is there. Guard means if you want that this switch is not participate in the STP elections. Okay, or you want that this switch is not able to becoming a root bridge. I want that switch. I don't want that switch one is becoming a root bridge. Okay, so then we can use guard option is there. Okay, so you can go for protects the switch to make root bridge. Understood?
Yeah.
Okay, fine. So this is what we have. This is the things we have. Okay. So this is the these are three options we already discussed. Okay, I'll let you know other options too. So we have a port fast, BPDU guard, and guard. Okay, so we can use these commands also. Like if I want to make becoming a particular port as a port fast, I want to up the port fastly. So I go for switch as you can say that switch 7, and I want that config t. Like imagine that I want to plug my server to a particular port. Like my server port is f0/8. Okay, I want that whenever I can plug my server on this particular port, that port is immediately up, not even take a single second. Okay, so then in that case we can use port fast. So how we can enable the port fast? Just go for interface, like interface f0/10 I can use. Okay, and now I'll go for spanning tree port fast. This is the command and enter it. Okay, it gives you the warning. It should make the loop. It's okay, but it's allowing you to up the port fastly. Now you can see that. Now if I go for if I check once, so I go to my switch 7 and I can attach one server. This is my server, as you can see that. I can attach a server or PC, whatever you can attach over there. Okay, and we can use the port 10. I use the port 10 and we can attach with this. You can see that, see, it even not take the single second this time. Understood? So it's automatic. It fastly, it means this is what we have a port fast command. So it gives you the RSTP. RSTP gives you this command, this functionality, port fast. So it means that you, if you want to immediately up the port without delay a single second, then you can go for port fast command is there. Okay.
Yeah.
So this is what we have a port fast command is this. Okay, so that's what we have a BPDU guard also. So we need to run the BPDU guard also in the configuration. Okay, and we can run the guard also option is there. Okay, now we'll discuss the port security and ether channel in upcoming lectures also. Okay, now after that, now after the RSTP, now still the problem is same. The second problem is same, and the first problem is okay. You can say that it's resolved perfectly because we have a port fast command is there. So we can less than less than delay a second, we can up the port. So the first problem is solved in RSTP, but the second problem is same. Okay, so for second problem, what they do, it resolves the second problem. It makes another protocol is known as PVSTP. PVSTP. As you can see that by default the switches works on PVSTP round. PVSTP. Okay, so the protocol name is per VLAN spanning tree. per VLAN spanning tree. Understood? Okay. So now over there, what we can do, like imagine that if I have VLANs in my switch, okay. So I can make my root bridge as per the VLANs. Okay. So like imagine like we have a switch over there, and we have another switch over there like this. Switch one, and that switch one we have two VLANs, VLAN 2, and over there we have VLAN 3. Okay. And we also switch 2. Over there we have a VLAN 2 and VLAN 3. So we did in this kind of things, we can create we can have two wires as per the VLAN. Like in VLAN 2 I can create two wires, I can plug two wires, and VLAN 3 also I can plug two wires like this. So what happens in that case, like if switch, if like imagine that, like imagine that in VLAN 2 this switch is a root bridge. Okay, so it blocks this port only. So if this block this port only, so what happens in that case, I'm able to send and receive the VLAN information with the help of another port, another interface. Okay, like imagine for VLAN 3, switch 2 is a root bridge, and it blocks this port. So with the help of another wire, we able to send or receive the VLAN database information. Okay, it means that in per VLAN spanning tree, it makes the root bridge as per the VLAN, as per the VLANs. It's not make the root bridge as per the switch. Understood? Okay.
Yeah.
So this is what we have a per VLAN spanning tree options. Okay. So this is what now if you see that with the help of PVSTP, this problem is solved. This second problem is solved now. Okay. So now in STP and RSTP, the problem is that it's avoid the loop, but it block the VLANs. But in that case, it avoids the loop too, and still my VLAN is also working in PVSTP.
Yeah.
Understood? Fine. Okay. So now PVSTP also made by Cisco. It's a Cisco proprietary protocol. Remember these things. So if you don't have a Cisco switch, so you're not able to use this. It is Cisco protocol. Okay, and it works on ISL only. There is no .1Q. Okay, so for that's why IEEE makes another protocol named PVSTP plus. Okay, and it supports both protocols, .1Q ISL and .1Q both. Understood?
Yeah.
Okay. So this is what we have a PVSTP and PVSTP plus. Okay, we have a RSTP also. Again now Cisco again comes in the picture, and it makes their Cisco proprietary protocol is known as RPVSTP. Okay, and the same concept is there, but it's for Cisco protocol only, works in Cisco switches only. Okay, and it works in this time in both the protocols, ISL and .1Q2. Okay, so as you can say that it's a competition between IEEE and Cisco in that case. Okay, once it found the protocol, then another one second it goes through the protocol. Okay, like this. Okay, and the last protocol made by IEEE is MSTP. MSTP is known as a mixed spanning tree protocol. Mixed spanning tree protocol. Now, what is the meaning of mixed spanning tree protocol? Is mixed means like if you are using, like imagine that one switch I'm using PVSTP and one switch I'm using RPVSTP. Okay, one switch I'm using per VLAN spanning tree protocol, and one switch I'm using rapid per VLAN spanning tree protocol. So with the help of MSTP, I'm able to communicate between different protocols too. Okay, so that's what we have a mixed spanning tree protocol. This is for mixed environment. Like in my network, I have a complex network, as you can say that. I have so many switches are there. So some switches are work in PVSTP and some switches are work in RPVSTP. Okay, so in that case, if I want to communicate those two switches, we can go for MSTP. Understood? Okay,
Mm-hmm.
that is known as a mixed spanning tree protocol. You can go for multiple spanning tree protocol too. Mixed or multiple, whatever you can call it. Mixed or multiple. This is for multiple. Okay, multiple means where you have a multiple protocols working, multiple spanning tree protocol is running. Okay, so in that case we can use MSTP.
Is one of these protocols the standard?
Which
The
one?
standard for
Standard is IEEE and IEEE only. So this is also a IEEE protocol, as you can say that.
yeah. I was referring as the default settings for the switches, or there is no such thing as a
No.
default setting?
The default setting is the switches works on PVSTP. Like if I showing you, like if I go for the switch, if I see the switch 7. So in switch 7, if I show spanning tree summary, so as you can see that it by default it works on PVSTP, means per VLAN spanning tree protocol.
Yeah.
Okay. Now your switch is not working with RSTP and STP. No. Okay. RSTP onwards, whatever the 5 functionality gives by RSTP, like port fast, okay, or BPDU message, BPDU guard, port security, Ether channel, all this functionality are available in all the STP protocols now. PVSTP also have this functionality. RSTP, RPVSTP also is also this functionality. PVSTP plus also this functionality. Okay, but this is my simulator, so it support only two versions. As you can see that if I go for show spanning tree mode, okay, sorry, config T, I go for spanning tree mode, so they're showing me only two: PVSTP, per VLAN spanning tree mode, and per VLAN spanning tree rapid, per VLAN rapid spanning tree mode.
Mm-hmm.
Okay, they gives me only two protocols because it's a simulator, that's why. If you go for live switches, so it support other protocols also, STP also, RSTP also, okay, PVSTP plus also, and some switches supports MSTP also, multiple or mixed spanning tree protocol also.
I see.
Okay, fine. So this is the simulators, that's why it support only PVSTP and PVSTP, RPVSTP. Okay, so if you want to change the mode, you can change the mode too. If you want to change the protocols, you can change the protocols too, as per the requirement, which protocol you want to go for that. So if you talk about the PVSTP or RPVSTP, it both works on the basis of VLAN. Okay, so these are the per VLAN spanning tree protocols. If you have a multiple VLAN running, so you need to run the multiple cables to per VLAN. Okay, and you can see that it created that go for that. Like if I showing you uh, the scenarios also, like I will do the PVST practical ones. So like we already have a switch, two switches with me. Okay, and what I do, I just first unplug this cable once. Okay, and in switch one first I make two VLANs. Like I go for VLAN 2 exit, VLAN 3 exit. Okay, in VLAN 2 and VLAN 3 I can add the ports also. So I go for interface range F0/122. I add in VLAN access switch port mode access, and I go for switch port access VLAN 2. Okay, now I'm going to add 3 and 4 in VLAN 3. Okay, so you go for interface range F0/3, sorry, 3 to 4, switch port mode access, switch port access VLAN 3. So as you can see that in switch 7, I go for change the host name also. So you go for host name, this is switch 7. Okay, so now in switch 7, as you can say that show VLAN. So in that, first two ports are in VLAN 2 and third 4 port is VLAN 3. Okay, I'll do same in switch 8 also. See. go for VLAN 2. Sorry, go for name, go for exit, then VLAN 3, exit, and then go for interface range F0/122 access VLAN 2. Okay, interface range F0/3 to 4. Then go for switch port mode access, then switch port access VLAN 3. Okay, so I just change the host name also. Okay, so as you can see that show VLAN. So in that also we have in port, so in VLAN 2 we have 1 and 2, and in VLAN 3 we have 3 and 4. Okay, now I make the now I see the wires. So I go for choose the cross cable. I plug 1 to 2, 1 to 1, port 2 to port 2, then port 3 to 3, and 4 to 4. Okay, every VLAN I can plug 2 wires. Okay, understood. Now you can see that which switch is a root bridge on which VLAN. Let's wait for a while, and then you can see that. Samuel, Huini, Gabriel understand these things, right?
Yep. As you explained, yeah.
Okay.
We're good.
Okay. Now, as you can see that, see, for every VLAN, switch 7 is a root bridge. Like if you go for see that, if you see that, if I showing you, go for show spanning tree summary. So over there, I'm sorry, not summary, show spanning tree, simple. Show spanning tree, that's it. Now, as you can see that, see closely. See, in VLAN 2, for VLAN 2, the root bridges, this is the root bridge, as you can see that. And in VLAN 3 also, this is the root bridge. Understand?
Yeah.
Okay, so it makes root bridge as per the VLANs, as you can see that. Okay, fine. So if I showing you see, if I showing you the things that you can see that every for every means every VLAN, it blocks one port, as you can see that.
Yeah.
Okay, so this is what we have, the PVSTP. Okay, and then if you see the ports also, you can see that in this switch every port is in forward mode. See, forward mode, and every port has every port has designated role. Why? Because this is the root bridge. So on root bridge, every port is a forward mode, and every port is becoming a designated port. Remember these things. Okay, fine. You can say that this is the hello time packet. This is the BPDU packet, BPDU message. It's every go for 2 seconds. Send every 2 seconds. Okay, and if I showing you on the switch 8, go for show spanning tree, enter it. So in that case, what we can see, we'll see that, see, as you can see that, see the port in VLAN 2, one port is block and one port is forward. Okay, and in VLAN 3 also, one port is block and one port is forward. And the block port is known as alternate port, and the forward port is known as root port. Understood? Because that port is goes forward to goes towards to the root bridge. So that's why this port is becoming a root bridge. Understood? Okay, root port. Sorry. Clear?
Yeah.
So this is what we have. We have a spanning tree. Okay, so these are the protocols we have. These are the modes we have. As you can see that we have so many modes are there. Okay, it starts with the you can say that it starts with STP, then PVSTP, then PVSTP plus, RSTP, RPVSTP, and MSTP. The total we have six protocols working in STP. Okay, fine. So which I already showing you that STP, and we have after that we have a RSTP, STP messages. Okay, and then in this slide we can understand the STP, and we have a RSTP. Okay, and RSTP onwards we have all these things: port fast, BPDU guard, port security, and ether channel, and then we have a PVSTP, PVSTP plus, RS, PVST, and MSTP. Okay, so total we have six six protocol which is working in the STP. Okay, but right now onwards switch also always working in PVSTP and RPVSTP. By default the switch works in PVSTP. Remember this thing, switch is not working now STP and RSTP by default. Okay,
Yep.
clear till now, right? So we already did the port fast practical. Okay, I already show you that how we can configure the port fast. Okay, now rest will do. Okay, okay. So do one thing now. Let's take 10 to 15 minutes break. Okay, at 4 o'clock. My side is 3:45. So at 4 o'clock we'll start the class again. Okay.
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 Okay, fine. Thank you. Okay, so everyone is there, right?
Yep. We are.
Yeah.
I am.
Okay. So we'll do these topics now. We'll need to complete these topics like the ether channel, okay, which you talk about, which RSTP gives these topics. Okay, so ether channel. We'll do this practical ether channel, and we'll go for port security as well. Port security. Okay, what is port security? Ether channel, and we'll go for that BPDU guard. I'll showing you how we can implement BPDU guard also. And now these is the major parts you can go for. Okay, like this. So we'll go for BPDU guard, and we're showing you the guard also. Okay, previously we already talked about the port fast. Okay, I hope you will able to understand the port fast concept. Okay, right now we'll start with the ether channel. Okay, now ether channel means over there is ether channel is a very good concept in switching. So what they go for that, like imagine that we have two switches. Okay, now I want that, like imagine that these switches ports has speed is very low. This switches port speed is very low. Like imagine I can able to access only 100 mbps. These are the 100 mbps ports, as you can see that in every switch. Okay, so I want to increase the speed. You can say that I want to increase the speed, or I want to bind the ports and make the speed increase. Okay, like I want that I want 300 mbps 300 mbps speed. Okay, between these two switches. So what I do, I use you can see that I make three wires over there like this. I use three ports, like there is a port one. You can say that port one, port two, okay, and port 3. You have a three ports like this, so I can connect all these three ports with the switch over there, port 1, port 2, and port 3. So we can use ether channel. So what happens in that case, like in one port they gives gives me 100 mbps and mbps speed, 100 mbps speed. And now you can say that all the ports gives me 100 mbps speed, but I want to combine these port speed. So what we can use ether channel in that case. Okay, so if what I do, I combine this speed like this. Okay, and now we can get as you can see that we can get 300 Mbps speed like this. So if I want to combine the port speeds, as you can see that I combine the 3 port as 1 port and work as a 1 port and provide the triple speed over there. So that in that case we can use Ether channel. Understood? Okay. If I want to combine the port speeds, if I want to combine the ports, as you can see that virtually. Okay. And if I want to access the more speed. Okay. So what we can do, we can merge the ports as well as their speeds, and we got that much speed. You can say that like this. Okay. If you want to merge the ports, if you want to get more speed, so we can use Ether channel in that case. Understood? Okay. This is what we have. Our Ether channel concept is. Okay. Now Ether channel, we have in Ether channel we have 2 protocols. One is PAGP. Okay, and second one is LACP. These are the 2 protocols we have. Okay. Now these 2 protocols. Now PAGP is a Cisco proprietary protocol. Again, it's a Cisco protocol, so it works only on Cisco routers. Okay, and PGP is a standard protocol. It works on every router. Whether if you have different routers also, different companies routers. So it's a standard protocol, as you can see that it's a standard protocol. Okay. We have two types of protocols, PAGP and LACP. So these are the 2 protocols we have. PGP is a Cisco proprietary protocol. It works only in Cisco routers, and LACP is a standard protocol. It works in every routers. Sorry, every switches. Okay. Now Ether channel also has a port rules also. We'll talk about the port rules too. Okay. Ether rules. Now one is active. Okay. Second is auto. Third is desirable. Okay, these are the some port roles we have. Okay, so I'll let you know what these port roles do. Okay, so like if I go for active, so active means what? Like if I using the same protocol on both the ends, like I using PAGP over there also and PAGP over there also. In that case, you can use active. Okay, if I talk about the auto, if I use the auto port or port role, so what happens in that case? Whenever protocol I can use over there in switch one, like imagine I can use PAGP, so automatically it use a PAGP on switch 2. Okay, I don't want to you can say that configure the protocol in another side. Okay, if I choose auto role, and if I go for desirable, so desirable means that if I choose over there PAGP, it also choose over there PAGP, and you can say that the speed is very high and all those stuff. So I was just showing you like, see, if I go for this, like if I showing you with this switch with the, we are using the layer 3 switch. Okay, like this, and what we can do, we can connect 3 wires between them. Okay, this is one part, this is the one second, and we'll go for third one. We'll connect 3 wires. Okay, and we have a PC also, PC1 and PC2. Now we'll go for I connect with port 4. I connect the PC2. Okay, first I set the IP address on the PCs. So this time I can use 10.0.0.1 because I'm in the switching. So we are using the same 10.0.0.2. Now, as you can say that your STP is working right now because it's a different port physically. That's why the STP is working over there. Okay, but when I connect these ports as Ether channel, so these 3 ports becoming a 1 port. So there is no STP working concept is there. Okay, once I create the Ether channel, okay, between these between these 2 ports, these 2 switches. Okay, so if I go to switch 2, and if I'm showing you, see, if I go for no and go for enable first, config T. Okay, and I can use this things in, like if I go for interface range. Okay, because I want to do work on all 3 ports. So I can use the range command over there, f0/1 to 3, enter it. Okay, now we have the option over there, channel. As you can say that this is the command of ether channel, channel group and channel protocol. Okay, so now once we'll see the okay, we'll go for ether. I don't think so. It's working in the packet tracer. This the command is channel group. Okay. That's right. Okay, channel group. Okay, like this. So if I go for a question mark over there, so as you can see that we have the two options over there. Okay, one is channel group and one is channel protocol. So first we can use the protocol option over there. So if I go for protocol, then they ask me which protocol you want to use, LACP and PAGP. So I'm using over there PAGP. Okay, now question mark and enter it. So as you can see that my ether channel protocol is selected. So first I select the ethernet channel protocol before I create the ether channel. First, I need to select the protocol. Now I'm going to create the ether channel. The command is ether channel hyphen group. Now I need to give how many groups we can create. We can create total 48 groups. So I give the number of the groups. So I go for group 1. This is the group 1. Now they ask me the mode of the ether channel. Okay, so go for mode. So we have these are the modes, as you can see that active, auto, desirable, on, passive. So active means enable LSCP unconditionally. It means it uses the LSCP protocol to create the ether channel if I using the active mode. Auto means enable PAGP only if a PAGP device is detected. Okay, so it means that if in switch 2 I'm using the PAGP, I'm using the auto. So in switch 3 also it's automatically run the PAGP protocol to make the ether channel. Understood? Okay, now we go for desirable. It's enable only PAGP unconditionally, so it works on only PAGP. There is no LACP. Like imagine that in switch 3 I'm using LACP. Okay, and in switch 2 I'm using PAGP. So we are not able to use the desirable. So if I go for desirable, so desirable only works on PAGP protocol. So we need to run both side PAGP protocol for desirable condition. Okay, now if you want to create only ether channel not using the protocols, then you can go for simple on. On means if you just click on mode, so in that case what we have, it uses the ether, it creates the ether channel for you automatically. It chooses the protocol automatically, and it uses the ether channel automatically. Okay, fine. Passive also enable LSCP only if a LSCP device is detected. So it works on only LSCP in passive mode. Okay, so like this. So right now we use desirable because we're using the PAGP protocol. Okay, on both the sides. In that case, we can use desirable. So you go for desirable over there. Okay, and then question mark, then it's enter. So as you can say that all the ports are automatically shut down and up. Okay, so as you can see that over there, all the ports turn into green, turn into orange. Previously they're showing me
Have
turn
some
into
connection.
green. Hello.
You have some.
Okay, the connection issue. Yeah, hello, now it's okay. Fine.
Okay.
Yeah, so what we can do, we can use desirable mode over there because I'm using the PAGP protocol only, so we can use desirable mode over there. Okay, we can create the group channel, we can create the channel, and we can create the group name is group 1. Okay, and we can use which protocol, we can use PAGP protocol in switch 2. As you can see that now switch 2, all the ports are green, turns to green again. Okay, now I'm going to switch 1. As you can see that, sorry, switch 3, the second switch, and I'll do the same thing in what we did in switch 2. I go for no over there. I'll go for enable. I go for config T. Okay, now I go for interface range command f0/1 to 3. Okay, now we can define the first, I need to define the protocol. So go for channel hyphen protocol. I use PAGP. Okay, and then we'll define the channel name. Channel group means, okay, I define the group 1. Okay, and then you can go for mode, and I am using the mode desirable and hit on enter. So as you can say that these ports are automatically shut down. Okay, for some time it's automatically up now. As you can see that it's making the ether channel, as you can see that on both the sides. Let's wait for some time, it automatically turns to green. See, now it turns to orange. Okay, now STB concept is finished. Now there is no STB concept is running in this switches, switch 2 and switch 3, because we are using the ether channel concept over there. Now you can see this. Now you can see that all the ports are running. You can see that. Okay, now if I showing you the ether channel summary, if I go to privilege mode and go for show ether channel summary. Okay, so you can see that we have one group. We can use the protocol PAGP, and all the ports are available in this channel. As you can see that port channel is pol SU, like this. Understood? Clear? Okay, so this is what we have. Port channel SU means, S means you can say that U means in use. Okay, and port means in security, P means in security, and S means we are using this. So this is what we have. So in switch 2, the ether channel is created. My channel name is channel 1, and all the ports are added in this channel, as you can see that. Okay, now you can go for switch 3 as well, and you can check once over there. You go for show ether channel summary and enter it. You can say that over there also the channel group 1 is created, and all the ports are created in this channel. P means port in the channel. As you can see that P means in port channel. So these all ports are in P status. You can see that these all ports are in the ether channel. So now what I do? I make this 3 ports virtually a one port, and we can send and receive the data. So now the speed, now we can got the multiple speed, as you can see that, as compared to 100 Mbps, now we can got 300 Mbps like this. Understood? Now if I want to try to ping with, so if I go to PC 14 and I'm trying to ping with 10.0.0.2, so it shows me reply, as you can see that. See, it shows me reply straight away. Okay, because they have a single port now. These 3 ports working as a single port virtually.
Yeah.
Understood?
Yeah.
Samuel. Okay. Heini. So understand
Yes.
those things, right? So this is what we have. Okay, so this is what we have. The ether channel it is. Okay. Now next we need to understand is port security. So if we talk about the port security, so what is the meaning of port security? Is that like imagine that I have a switch over there. Okay, and port security means that, like, imagine this is my major switch. You can say that this is my main switch. You can say that. Okay, and I have a PCs too with this switch. So you can say that I have a 4 PCs like this. Okay, so we have a 4 PCs like this. Okay, and this I attach this switches. You can say that, like, I can attach this switch port 1 to this PC. Okay, and I can attach. I'm not touching anything over there right now. Okay, fine. So now I have a port 2 also. So I attach port 2 on this PC, the 17 one. Okay. Now what happens in that case? Imagine that some you can say that some unauthorized person is there. Okay, he wants to modify this switch. Okay, so what he can do? He just what he do? He remove this wire. Okay, to this PC, and he plug this wire to their PC, and is able to access the switch, right? So there is no security, there is nothing is there. Okay, so I want that this if this switch if this PC is changed, like imagine if someone trying to connect this port on to their PC, so the port is automatically shut down. You can say that. Or there is a violation, if there is any violation is there, okay, so I want that the port is automatically shut down, so the other person is not able to access with the help of this port, other person is not able to access their PC on this port. Understood? Okay, so that's what we have, a port security option we have, because we have a port security options also there. Okay, so in the port security what we have, uh, like by default your one port is remember 132 MAC addresses by default. Remember these things. If we talk about the switch port, so switch one port is able to remember 132 MAC addresses easily. Okay, so like imagine that if I go there, if I go there, if I go for enable and go for config T, and I want to apply the port security on port F0/2. Okay, so I go to first I need to check the MAC address table over there. So I go to exit. So I right now the MAC address table is empty. Show MAC address table. So as you can say that right now the MAC address table is empty. If it is not empty, we can clear the MAC address table too. So we have the option clear MAC address table. So it's clear your MAC address table. Okay, fine. So right now the MAC address table is empty. So there is no MAC address remembering to any port right now on the switch. Okay, because there is no traffic right now. It's a new, or you can say that fresh switch. There is no traffic is there. So that's why no one means that nothing MAC address is there maintained by this switch. Okay, now what I need to do, okay, now I need to apply the port security on F0/2. Okay, so what I need to do now, I go to config T, go for interface F0/2. Okay, now before I start applying the port security, your port must be on a access mode. Remember these things. If your port is on a trunk mode or a dynamic desirable mode, so you're not able to apply the port security on a particular port. So your port must be on a your port must be on a which mode? Access mode. So first I need to change this mode to access. Okay, fine. Now in port security, I need to first define that how many IP addresses this port is able to learn. Okay, so I want that is able to learn only one MAC address only on for this PC only, the PC2, which I already configured the PC. That's it. Okay, this port is not able to, if someone is trying to you can say that if someone is trying to change the PC, okay, the port is automatically shut down. I want this. Okay, understood? Fine.
Yeah.
Okay. Oh, just a minute. Okay, so now we need to go for that. So now I'll start the port security commands. Okay, so over there we need to define first switch port security. Now we need to define first the MAC you can say that we can go for MAC address, we can go for maximum command first. So first we need to go for maximum command. So maximum command is maximum command. Now maximum, how many MAC address you want to learn on this port. So I want that. So to write total, it's a port, it learn 132 maximum. Okay, so I want that only one MAC address, not more than that. Okay, fine. So I'll go for that. So this is the command I run first. Now after that I want to enable the port security. So go for switch port security. I want to enable the port security also. Now the port security is enabled on this particular port. And now the next command we need to understand is that how this like you can see that if you go for port security and go for question mark, so we have the option MAC address. Now you want to write the MAC address manually, means this switch you want to learn the MAC address manually, or you want to learn the MAC address automatically on this switch. Okay, so if you want to learn the MAC address manually, you can define the MAC address manually over there. So you need to define the MAC address, PC17 MAC address on this port manually. You can go for like MAC address and then you can define the MAC address full. Okay, if you want to learn the MAC address manually on the switch on this port, if you want to learn the MAC address automatically, okay, then we have the command. You can go for MAC address. Then we have the option. You can define the MAC address manually, or we have the option sticky. Okay, if I go for sticky, so it means that it's automatically learn the MAC address. Okay, just hit on enter. It's sticky. The sticky means it's automatically learn the MAC address. We don't want to go for that. Okay, now we have the option of violation also. So you have the violation methods too. Violation, in violation, what type of violation you want? If there is a violation, what your port do? Port, it's automatically go for shutdown. I want that port automatically goes to shutdown. That's it. What violation I set on this port. Okay, so what commands you set on this port? I go for show, run. So these are the commands we'll set on this port. Okay, on the port 2, we'll add this mode access, then enable port security, and then we can go for port security MAC address sticky. Sticky means it's automatically remember the MAC address. Okay, dynamically it's dynamically remember the MAC address, and the maximum MAC address I can learn is only 1. Okay, fine, understand this. Now we'll see. Now we'll first I do some traffic. I'll generate some traffic. As you can see that I go for ping 10.0.0.2. The PC17 address is 10.0.0.2. If I enter it, okay, I just check once whether I set the IP addresses. No, I'm sorry. We'll set the IP address first. 10.0.0.3. I'll go for there, and we'll go for there is 10.0.0.4. Okay, now we'll start the pinging. Let's start the pinging now. Now ping 10.0.0.4 and enter it. Now it's showing you the reply. Now if you see that, if I go to my switch and we'll see show MAC address table. So as you can say that dynamically it's learn only the one MAC address. Okay, F0/1. Okay, it's learned the MAC address 1 only. Okay, in F0/2, it learns the MAC address also statically. It's go for this is so this PC MAC address is learned. So if I go for show port security, as you can say that, so in that you can say that the maximum MAC address is 1. Okay, and the current also MAC count is 1. So maximum MAC address count is 1, and the current also count is 1. Okay, now imagine that if I going to change this, first I define the IP address on this port also, 10.0.0.5 for this PC. Now what I do, I remove this wire and I'm going to change this to this PC number 18 now. Okay, now what happens? Now if I showing you on the switch, so still you can say that still the counting is 1 only. Okay, and if I go for MAC address table, still it's remembering only the one MAC address. Okay, now if I'm trying to ping with this PC, if we're trying to send the data, like go for ping 10.0.0.5 and enter it. While I start the pinging, as you can say that it's blocked the port. I was seeing it. It's showing you the red port now. Now if you see that if I go to the switch and if I'll try to check the port security, so as you can say that there is a violation is there. One violation is there. That's why the security action is port is shut down. Understood?
Yeah.
Okay, so that's what we have a port security. So as you can see that now I'm not able to access this port. Why? Because there is a violation occur. Okay, someone is trying to access my port. Okay, so that's what we have a port security. So with the help of port security, we can secure our switch ports too. Okay, so this is also the gives you by STP protocols. This feature also gives you by STP protocol. Okay, understand all of you? Samuels, Gabriel,
Yeah.
Right. Okay. So this is what we have, other things, Ether channel and port security. Okay. Now next we need to go for BPDU guard. So BPDU guard is that if you want to protect your switch from BPDU guard, okay, or you don't want to define a particular, or you don't want to send the BPDU message on a particular port. Okay. So in that case, we can use BPDU guard. So like if I want that, okay, like if I want that, I want that.
Yeah, I have a question
Yeah,
regarding this
port security.
port shutdown.
Okay.
If we change the link back to our first PC, the
Mhm.
port will still remain shut down, yeah?
Yeah, it's still remaining shut down because the
And
violation is occur only already.
and if we change the state of the port from the switch manually,
Mhm. Then
it
it's
will
automatically
go
default.
back to shut down.
You need to clear the MAC address table in that case. Okay, we have the option. We need to clear the MAC address table and then we can go again to send the traffic. In that
I
case, that
see.
port is automatically up because in MAC
And
address table,
then
we
is
already maintain the MAC addresses. No, that's why.
yes for the PC17.
Yeah,
And if we clear the
MAC
table
address table. Yeah,
and we enable the port, it will learn the PC18 Mac.
yeah,
Yeah.
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 That's all.
Okay.
Understood. Okay. Okay. So now I will talk about the PPTU guards. If I need to block someone port that I don't want to send the BPTU message on a particular port, so we can use BPTU guard. Okay. So I'll go for config t. Like imagine that I have a port 3. I want that on port 3, BPTU messages are not able to send. Okay. So I'll go for interface f0/3 and I'll go for spanning tree. BPDU guard. Here it is, and enter it. Oh, sorry, spanning tree BPDU guard, and we go for disabled or enabled. So I want to enable it. Okay. So now on this switch, on this port, as you can see that on port number 3, BPDU messages are not receiving. Means you can say that port number 3 is not able to receive BPDU messages. Understood? Okay.
Yeah.
So this is what we have. Okay, if you want to use the filter, if you want to check the, you can say that if you want to check whether you're able to send or receive the BPDU packets or not. Okay, so you can use the BPDU filter option is also there. Okay, we have the option BPDU filter also option is also there. Okay, if you want to check, so I think so maybe this BPDU filter. Maybe no, I don't think so. It's running this. Yeah, BPDU filter option is not there. So BPDU filter is used to check to monitor the BPDU packets, whether this port is able to accept the BPDU packets or not. So this command is running in the live devices. Okay, so the command is spanning tree BPDU filter, and then we need to enable or disable the BPDU filter.
Mhm.
Understood. So with the help of BPDU filter, we can check whether this port is able to receive the BPDU packet means packets or not. Fine. Done. So this is what we have, a BPDU guard option is there. Okay. Okay. Now, if you want to run the guard command, so we have the guard command also is there. Guard command is what? If you want to not participate, if you want that this port this port is not participate in the STP elections. Okay. So the simple is running spanning tree, and you can go for guard, and that is and go for. So you can say that I don't want to make this port as a root bridge. Okay, then go for root. That's it. I hit on enter. So now once you run this command, what happens in that case? Now this port is not participate in the root bridge elections. in the STP elections, as you can see that, and this you can see that switch is not becoming a root bridge.
Mhm.
Understood? Okay, fine.
Yeah.
So these are the practicals we need to understand. Okay, ether channel, port security, BPDU guard. Okay, port first we already did. Okay, so this is what we have in ports in STP. Okay,
Yeah.
so we successfully complete the switching part. Okay, as per we configure VLAN, VTP, STP, inter-VLAN routing. Okay, all the stuffs in this BPDU filter also. We already see the BPDU filter also. I'll give you the explanation only. The BPDU port fast is there, post fast is there, BPDU guard is there, BPDU filter is also there. Okay, so that's what we have. Okay, and you can see that in switching. Okay, I hope you're able to understand all the switching part, right? Everyone, not only
Yeah.
Daniel.
Yeah.
Okay, so
It's a lot of information to process.
okay, so you are doing practice with me or
Trying sometimes, but you're fast. But it's okay.
I'm fast. Okay, okay, it's okay. So once you see this recording again, and that time you can do the practice. So if you have any issues, any doubts, at least you can pause the recording and then you can repeat again. Okay. So we'll see once. Just wait. I hope that is for the switching part. And just check once. Yeah, okay, network fundamental is there, TCP, UDP, IP addressing. And then we have a network, so VLAN connectivity, trunk ports, native VLAN, layer 2, layer 3 switches, ether channel. Okay, that's it. Telnet, SSH, HTTP, trunk ports. Okay, so we almost complete the switching part. Okay, so I hope you're able to understand all the topics till now. Okay, all right.
Yeah. We need to practice.
Yeah, you need to practice. So if you want to practice, I'll give some time to you. Okay, if you want to do practice, because after the class you don't have. I don't think so. You have that much time to do the practice, right?
Yeah.
So if you want to do some practice to the switching part totally. Okay, because you already complete the switching part. And next class onwards, I'll start the start routing part. Okay, so routing means we need to cover the stuff like, I'll let you know what we need to cover in the routing part. Okay, so in this we need to start with the very basics of routing. Okay, basic of routing, and next we need to go for the static routing. We need to cover the static routing too. Static routing, and then we can go for the routing protocols. In routing protocols, we need to learn go for RIP. Okay, EIGRP and OSPF. In RIP, we can go for RIP version 1, version 2 both. Okay, version 1 and version 2 both, and version 2. And then after that this we'll go for some access list concept, ACL. Okay, we'll go for NAT-PAT, these things, NAT and PAT. Okay, and we'll go for some HRP, something like GLVP, VB, sorry, and HSRP. Well, this is the concepts we have. Okay, so this is the major concept of routing. Okay, so in next two classes we need to complete the routing, and then the last class on the 5th day we'll go for automation and some wireless concepts and all the stuffs.
Mhm.
Okay, fine, because automation is a new in CCNA version 3. Okay, Automation, in automation we have some new means the full automation part is new. Okay, wireless is also previous in previous old curriculum, wireless is also there, but in the new curriculum, as you can say that we have a new this automation part is there. Okay, so we need to understand the automation part. This and networking fundamentals, network access. This is the switching, the routing. Okay, and these are the security fundamentals and automation. These are the some new parts out there like VPN, DHCP, DNS. These are the security parts. Okay, and we need to understand the automation part too. So automation is a new part in CCNA version 3. So we need to understand this full. It's a new in CCNA version 3. Okay, fine.
What is it and in which language do you need to program it?
In which? In automation?
Mm-hmm.
Yeah, in automation, we have some different concepts are there. So we have some data center concept is there. We have some programming or encoding concept is also there. So we need to see this automation. This is a very good part in CCNA. Okay, it's a new in CCNA, as you can say that. Fine. Okay, so we'll see on the last day, automation and security. Okay, so till day 4th we need to complete the routing part, and then on the day 5th we'll go for security and automation. Okay, fine. Okay, so if you want to do practice, you can do practice. Okay, because today part is I already completed the today part. The switching I already completed. Okay, if you want to do the practice of switching part, you have some time left. So you want to do practice, you can do practice. Okay, if you have any doubt, anything, please let me know.
Yeah.
Okay, fine. So because you have still 2 hours, maybe 1.5 or 2 hours left. So if you want to do practice, then do practice. Okay. Okay, Samuel. Okay.
Okay.
So
Sure.
just try to do practice. Okay, I'm available online over there. Okay, so if you have any doubt, anything, please let me know. Okay, or if you want to share the screen with me, so I'll make you as a host also. Maybe they have options also there. Okay, and you want give you this recording too. Okay, I'll give you the recording, so then you can able to
Yeah.
go for
Okay.
that. Okay. Fine. So I'm available there online. Okay. So you have at least 2 hours till now. So start doing practice. If you have any doubt, anything, please let me know. Okay. Start doing on the basics. Start with the basics and then go for means all the practical which we did till now in the class. Okay.
Maybe you have some examples for us for practice.
Okay. I'll give you some examples. Okay. I'll give you some examples. Then you're able to do practice. It's fine with you,
Yeah.
right? Okay.
Yeah.
Okay, so I'll give you some examples. Just wait. I open the notepad over there. Sorry. Okay. Let me give you an example. Okay. Okay. Wait. I have a task. Okay. Means draw this table. Means draw this diagram as compared to I go from MS Paint. Like this. Like draw this diagram like this. We have switch. Okay, switch 1, switch 2, and switch 3. Okay, fine. What
Yeah.
you have to do on this switches? Switch 1, make 4 PCs to every switch. Make means connect 4 PCs to every switch. Okay. and we'll go for like PC1, PC2, PC3, PC4, PC5, PC6, PC7, PC8, PC9, PC10, PC11, PC12, like this. Okay, so you need to attach four PCs to every switch. Okay, like this, and attach like this. Okay, fine. Now what do you need to do? You need to configure number one. You need to configure. You need to set the passwords first. Okay, set enable secret password on all the switches. Okay, fine. Now next, you need to set enable telnet, as you can see that, on all the switches. Number third, make VLANs. Okay, make VLANs means like yes, like this. You can go for that. No, like you have to understand the things. Means step by step, because if you like see, we already did the practicals. Okay, but when you go for start making the labs, you need to go for one by one. So you're able to understand the things properly. That what we need to do first, and then we can do first, and then we can do first, like this. Okay, fine.
Yeah.
So create two VLANs on switch one. Okay, switch one, and add the ports in the VLAN. Okay, and in switch two, and switch three, use VTP or configure VTP, as you can see that. Configure VTP. Make switch 2 as server and switch 3 as client. Okay, use VTP password also. Okay, fine. Try to do this. Okay, till now. Try to do this first, and then we'll do further. Okay.
Okay.
Try to do this first. Okay, you need to do this first. Configure passwords on all the switches, and then configure telnet on all the switches, and then create two VLANs on switch one. Add the ports, and in switch 2 and 3, you need to use VTP. Make switch 2 as a server and make switch 3 as a client, and create VLANs with the help of server. And you need to configure the VTP password too. Okay, try to do this much amount of practical, and then we'll see the further things. Okay.
Yeah. Okay.
Okay, start doing practical. I'm online available over there. Okay, if you have any doubt, anything,